Imagine a star so massive, so gigantic, that it stretches across space in ways we can barely comprehend. A star so bloated that its outer layers are barely holding together, making it one of the most extreme objects in the universe. But what if I told you that some of the biggest stars in the cosmos aren't as dense as you might think? That they are so puffy, their outer layers are almost floating away? These are the Puffy Supergiant stars, some of the strangest and most mysterious stars ever discovered. They challenge everything we thought we knew about how stars evolve, how they live, and how they die. And what's even crazier? Scientists are still struggling to understand why they exist at all. These bizarre stars defy expectations. When you think of a supergiant, you might imagine a massive, dense ball of plasma, burning at millions of degrees, crushing itself with gravity. But Puffy supergiants? They are the opposite. Their outer layers are so extended, so loosely bound, that they make even other supergiants look compact. These stars are so big that if you replaced our Sun with one, it wouldn't just swallow Mercury and Venus, it would engulf Earth, Mars, and stretch way beyond the orbit of Jupiter. And yet, despite their size, they're barely holding together, making them one of the biggest mysteries in astrophysics. To understand why these stars are so weird, let's break down what makes a star puffy in the first place. In a normal star, gravity pulls everything inward while pressure from nuclear fusion pushes outward. It's a delicate balance. But in puffy supergiants, something is off. The outward pressure is so extreme that their outer layers expand to incredible distances. This makes them much less dense than typical stars of their size. In fact, if you could somehow stand on one of these stars, not that you'd want to, considering the surface temperature and radiation, you'd probably just sink right in, like stepping into a cloud of hot gas. But what's causing this insane expansion? That's where things get even more interesting. Scientists believe that extreme radiation pressure is playing a huge role. These stars are so luminous that their own light is pushing their outer layers outward, making them inflate like a balloon. It's like if you had a fire so hot that it physically pushed everything around it away. The problem? That kind of power shouldn't last long. A star that unstable should burn through its fuel quickly and collapse or explode. And yet these stars exist. So how are they maintaining their structure without immediately tearing themselves apart? One theory is that puffy supergiants are in a very brief but dramatic phase of their evolution. They might have started as regular supergiants, but reached a tipping point where their internal structure became unstable. Another idea is that they could be in the process of shedding mass at an incredible rate, throwing off huge amounts of material into space while their core remains intact, at least for now. Some scientists think these stars could be connected to massive supernova explosions, or even the formation of black holes. If that's true, then puffy supergiants might be the last stage before a spectacular and violent end. And here's where things get even weirder. Some of these stars don't just stay puffy. They pulse. They expand and contract in cycles, almost as if they're breathing. This pulsation isn't random. It follows a pattern that scientists are still trying to fully understand. In some cases, these stars shed massive amounts of material in dramatic bursts, creating enormous clouds of gas and dust around them. These clouds can block our view, making it even harder to study what's going on. But sometimes, when we get a clear look, we see something that shouldn't even be possible. A star that looks like it's holding itself together by sheer force of will. This raises another question. How do puffy supergiants form in the first place? What kind of conditions create a star this extreme? Most stars follow a predictable life cycle. They form from clouds of gas and dust, burn through their hydrogen, expand into giants, and eventually either shrink down into a white dwarf, explode in a supernova, or collapse into a black hole. But puffy supergiants don't fit neatly into this pattern. They seem to be caught in a strange in-between state, one that astrophysicists are still struggling to explain. One possibility is that these stars started off as massive normal stars but encountered some kind of disruption, maybe a violent interaction with another star or even a hidden companion that's affecting their evolution. Another idea is that they formed in an environment with just the right conditions for extreme expansion, such as a region of space rich in certain elements that make their outer layers more unstable. And then there's the idea that these stars might not actually be that rare. We just haven't been able to detect them properly because of their surrounding dust clouds and the way they interact with light. There's another mystery here, too. Some puffy supergiants have been observed in galaxies that are billions of light years away, meaning they existed in the early universe. This raises a big question. Were these stars more common in the past? If so, that could mean they played a key role in shaping the evolution of galaxies, enriching space with heavy elements that later formed planets, moons, and even life itself. But if they were more common back then, why are they so rare now? Did the universe change in a way that made it harder for them to form, or are we just missing something important about how stars evolve over time? One of the most famous suspected puffy supergiants ever observed is a star that seemed to defy all logic. It was so massive, so unstable, that astronomers expected it to explode in a dramatic supernova. But instead of blowing up, it just disappeared. No explosion. No bright flash. Just gone. This has led some scientists to believe that some of these stars might be skipping the supernova stage altogether and collapsing directly into black holes without any warning. If that's true, then puffy supergiants might be the missing link in one of astrophysics' biggest mysteries: how some black holes form without producing a detectable explosion. And this is just the beginning. The more we study these stars, the more questions arise. Are they a temporary stage in the life of all massive stars, or are they something entirely different? Could they be responsible for some of the most extreme events in the universe, like long-duration gamma-ray bursts or hypernovae? And most importantly, how long do they last before they inevitably meet their fate? If there's one thing we know for sure, it's that puffy supergiant stars challenge everything we thought we understood about how stars live and die. They sit on the edge of astrophysical possibility, existing in a delicate balance that shouldn't even be possible. But they are real. They are out there, floating in the vastness of space, defying expectations and leaving us with more questions than answers. These strange stars are a riddle wrapped in a mystery, floating in the vastness of space with no clear explanation for their existence. Scientists have theories, but the truth is, we still don't fully understand why these stars are so different from everything else we've observed. And that's what makes them so fascinating. One of the biggest puzzles is their lifespan. Typical massive stars burn through their fuel relatively quickly, often living just a few million years before reaching their explosive end. But puffy supergiants? Their extreme expansion should make them unstable, meaning they shouldn't last long at all. Yet we've observed some of them existing for surprisingly long periods. How is that even possible? What force is keeping them from collapsing or blowing apart? One possibility is that their internal pressure is in a constant tug-of-war, expanding and contracting over time. This would explain why some of them pulse in brightness, almost as if they're inhaling and exhaling on a cosmic scale. But even that doesn't fully answer the question. Some of these stars are so large and so loosely held together that their outer layers should just be drifting away into space. In fact, some scientists believe that these stars may be in the process of losing massive amounts of their mass, shedding material at an unprecedented rate. This could mean that what we're seeing as a puffy supergiant is actually just a brief, transitional phase, a star caught in the act of tearing itself apart. And that brings us to another mind-bending idea. What if these stars are actually in the process of turning into something else? What if puffy supergiants are a key step in the creation of the most extreme objects in the universe, like neutron stars or black holes? If that's true, then these stars might not just be a curiosity. They could be one of the missing links in our understanding of stellar evolution. Some astronomers believe that puffy supergiants might be the direct predecessors to hypernovae, ultra-powerful supernovae that release more energy than nearly any other event in the universe. A hypernova is basically a supernova on steroids, capable of producing long-duration gamma-ray bursts, the most energetic explosions we've ever detected. If puffy supergiants are indeed the stars responsible for these events, then studying them could help us understand not just how stars die, but also how they leave behind some of the most extreme remnants in the cosmos. But what if some of these stars don't explode at all? What if, instead of going supernova, they simply collapse under their own weight and form a black hole in complete silence? This would explain a long-standing mystery in astrophysics: why some massive stars seem to vanish without a trace. Normally, when a star explodes, we see a bright flash of light followed by a slowly fading remnant. But in some cases, astronomers have observed massive stars that just disappear from the sky, with no explosion, no fading light, nothing. Could Puffy supergiants be the missing link in this phenomenon? Could they be so unstable that, instead of going supernova, they just collapse directly into black holes? The idea isn't as far-fetched as it sounds. In fact, some scientists believe that stars above a certain mass threshold might be able to bypass the traditional supernova stage entirely. Instead of exploding, their cores would collapse so quickly that not even light could escape, instantly forming a black hole. If Puffy supergiants fall into this category, then they could be responsible for creating some of the largest black holes in the universe. But there's another possibility, one that's even stranger. What if some Puffy supergiants don't just collapse into black holes but instead create something even more exotic? Some physicists have speculated that under the right conditions, a collapsing supergiant could form what's known as a quark star, a hypothetical type of star made entirely of quarks, the fundamental building blocks of matter. If these objects exist, they would be even denser than neutron stars but not quite black holes. Could Puffy supergiants be the missing link in the formation of these mysterious objects? This brings us to an even bigger question: how do we even detect and study these stars? Because of their loose, extended outer layers, Puffy supergiants can sometimes be difficult to observe directly. They are often surrounded by thick clouds of gas and dust, making them appear dimmer than they actually are. In some cases, they might even be mistaken for other types of stars, which means there could be far more of them out there than we currently realize. One way scientists are trying to uncover more of these stars is by looking for their unique light signatures. Because of their extreme size and instability, Puffy supergiants often produce irregular bursts of brightness. These fluctuations can be detected by powerful telescopes, allowing astronomers to identify potential candidates for further study. Another method involves looking for the remnants of these stars, massive shells of gas that were once part of the star's outer layers. If we can track down these expanding clouds of material, we might be able to piece together a clearer picture of how these stars evolve over time. And then there's the possibility that some of these stars are hiding in plain sight. Because Puffy supergiants are often surrounded by thick layers of dust, they might only be visible in certain wavelengths of light, such as infrared, which can penetrate dust clouds more effectively than visible light. This means that the next major breakthrough in understanding these stars might come from specialized space telescopes that can see beyond what the human eye can detect. But perhaps the biggest mystery of all is whether these stars are as rare as they seem. Right now, Puffy supergiants are considered an unusual phenomenon, but what if that's only because we haven't been looking for them in the right way? If they turn out to be more common than we thought, that could completely change our understanding of how stars evolve and die. It could mean that the universe has been hiding an entire population of extreme, unstable stars that we've only just begun to uncover. And if that's the case, then what other secrets are waiting to be discovered? If Puffy supergiants are out there, defying everything we thought we knew about stellar physics, then what else could be lurking in the vast, unexplored depths of space? The truth is, every time we think we have the universe figured out, something comes along that forces us to rethink everything. Puffy supergiants are just one example of how little we truly understand about the cosmos. And as we continue to peer deeper into the universe, who knows what other mysteries we'll uncover? The deeper we dive into the mystery of Puffy supergiant stars, the more questions arise. What if these stars represent a stage of stellar evolution that we never even considered? What if they aren't just unstable giants, but rather, evidence of a completely new process at work in the universe? Some astronomers speculate that these stars could be the result of extreme mergers, massive collisions between two already giant stars. When two stars in a binary system merge, the result can be a brief but intense period of expansion, creating a bloated, unstable object that resembles a Puffy supergiant. If this is true, then some of the Puffy supergiants we see might not be single stars at all, but the aftermath of violent cosmic crashes. This could also explain their unusual instability. If their cores haven't fully settled into equilibrium after merging, the energy fluctuations could be responsible for their bizarre behavior. But what if some of these stars are even stranger than that? Some scientists have proposed that certain puffy supergiants could be what's known as Thornsico objects, a theoretical type of star where a neutron star is swallowed by a supergiant. In this scenario, a supermassive star expands to such an extent that its outer layers engulf a neutron star that was once in orbit around it. The neutron star then sinks into the center of the giant, creating an extremely unusual and chaotic stellar structure. If this is happening inside some of these stars, it would make them some of the most exotic objects in existence, giant, swollen stars with superdense neutron star cores. This theory is supported by the idea that some puffy supergiants exhibit unusual chemical signatures, elements that shouldn't normally be present in such large quantities in a regular supergiant. The reason? If a neutron star is present inside one of these objects, it could trigger unique nuclear reactions, producing exotic elements that we wouldn't normally expect to see in a typical star. Detecting these signatures could help us determine whether some of these stars are actually harboring hidden neutron stars within them. But even if that's not the case, there's still the problem of how these stars manage to hold themselves together. The larger a star gets, the more difficult it is for gravity to maintain control over its structure. And with puffy supergiants being some of the largest stars ever detected, it seems like they should be on the verge of breaking apart at any moment. In fact, some of these stars are so loosely held together that their outer layers might not even be fully bound to them anymore. Instead, they could be surrounded by a thin halo of gas, slowly escaping into space, a sign that these stars are already in the process of dissolving. And if that's the case, then what's left behind? Do they shrink down into smaller, denser stars? Or do they simply fade away, leaving nothing but a cloud of gas in their wake? One theory suggests that some puffy supergiants might not actually explode at all, but rather just disperse their outer layers gradually until all that's left is a bare, exposed core. If this is true, then we could be looking at an entirely new way for stars to end their lives, one that doesn't involve supernovae or violent explosions, but rather a slow and silent death. But here's the wildest possibility. What if some of these stars are actually precursors to something even more extreme? Some researchers have speculated that under the right conditions, a puffy supergiant could collapse not into a regular black hole, but into what's known as a direct collapse black hole, a black hole that forms without any visible explosion. Normally, black holes are created after a star goes supernova, but in some cases, the collapse might happen so quickly that no light is emitted at all. If this is happening with puffy supergiants, then we might be witnessing the formation of some of the universe's most massive black holes without even realizing it. This could also tie into another mystery, the existence of supermassive black holes. Most black holes form from dying stars, but supermassive black holes, like the ones found at the centers of galaxies, are so large that it's unclear how they could have formed in such a short amount of time. Some scientists believe that these black holes might have started as seed black holes formed by direct collapse, skipping the supernova phase entirely. If puffy supergiants are involved in this process, then they could be one of the missing links in explaining how the universe's largest black holes came to be. But what if we're thinking about this all wrong? What if puffy supergiants aren't dying stars at all, but rather newborn stars that just haven't settled into their final forms yet? Some astronomers have considered the idea that these stars could be in an early, unstable phase of their evolution, a temporary state before they contract into more stable supergiants, or hypergiants. If this is the case, then these stars might be some of the youngest massive stars in the universe, still in the process of forming their final structures. This would mean that we're not looking at dying stars, but rather, stars that are still in their infancy. Giant, chaotic spheres of gas that haven't yet figured out what they want to be. If true, then puffy supergiants could represent a stage of stellar formation that we never even realized existed. And then there's the question of their role in the larger cosmic ecosystem. If these stars are losing mass at extreme rates, then they could be some of the biggest contributors to the chemical enrichment of the universe. When a star sheds its outer layers, it releases heavy elements into space, elements that later go on to form new stars, planets, and even life. If puffy supergiants are dispersing their material at unprecedented speeds, then they could be responsible for seeding the next generation of stars with the building blocks needed to form complex planetary systems. So, what does all of this mean? It means that puffy supergiants aren't just strange anomalies. They could be one of the most important pieces of the puzzle when it comes to understanding the life and death of stars. They challenge everything we thought we knew about stellar evolution, and they raise more questions than they answer. How many of them are out there? Are they really just unstable giants, or are they part of a larger process we haven't yet discovered? Could they be the key to understanding black holes, supernovae, and even the origins of the universe's most massive structures? One thing's for sure, the more we study these bizarre stars, the more we realize how little we truly know about the universe. And if puffy supergiants are any indication, then there are still countless cosmic mysteries waiting to be uncovered, mysteries that could completely change our understanding of space and time itself. The mystery of puffy supergiant stars isn't just about their size or instability, it's about what they represent. They challenge our fundamental understanding of how stars work, how they evolve, and what happens to them when they die. For decades, scientists believed that the life cycle of a massive star followed a predictable path. They formed, burned through their fuel, expanded into red giants or supergiants, and then exploded in a dramatic supernova before collapsing into a neutron star or black hole. But puffy supergiants don't fit neatly into this model. They exist in a strange, in-between state that defies conventional stellar evolution. One of the biggest questions surrounding these stars is their internal structure. Most supergiants have a well-defined core, where nuclear fusion occurs, and outer layers that gradually lose mass over time. But puffy supergiants appear to be more chaotic. Their outer envelopes are so bloated and diffuse that it's unclear if they even have a stable core at all. Some models suggest that instead of a well-defined, compact core, they might contain multiple layers of turbulent convection zones, where heat and radiation are chaotically mixing instead of following the structured patterns seen in more stable stars. This could explain why they are so unstable. If their internal structure is constantly shifting, then the balance between gravity and radiation pressure that keeps a normal star intact is constantly being disrupted. This instability might also be why they pulsate so wildly. Some of these stars experience rapid fluctuations in brightness, expanding and contracting unpredictably. These pulsations could be a sign that their interiors are constantly readjusting, struggling to maintain equilibrium but never quite succeeding. And that raises another possibility. What if puffy supergiants are actually in the process of collapsing even as we observe them? Some theories suggest that these stars are so unstable that they might be in the final moments before they undergo gravitational collapse. Instead of exploding in a supernova, they could be directly collapsing into black holes in real time, without any warning. This idea is supported by the fact that some massive stars have been observed to suddenly disappear from view without any detectable explosion. If these disappearing stars were actually puffy supergiants, then they might be undergoing a process that astrophysicists never expected, collapsing into black holes without releasing enough energy to produce a supernova. This could also explain another cosmic mystery: the origin of intermediate mass black holes. Most black holes we detect are either stellar mass black holes, which form from regular supernovae, or supermassive black holes, which exist at the centers of galaxies. But in between these two extremes, there is a missing category: intermediate mass black holes, which are thought to be dozens or even hundreds of times the mass of the Sun. These objects are difficult to detect, and their formation is not well understood. If puffy supergiants are collapsing directly into black holes without supernovae, then they could be the missing link in the formation of these intermediate mass black holes. But there's another problem. If these stars are constantly losing mass at extreme rates, then how do they even exist long enough to collapse at all? Theoretically, they should be shedding their outer layers so quickly that they should burn themselves out before they ever have a chance to become black holes. Some astronomers believe that these stars might not last long at all. They could be some of the shortest-lived stars in the universe, existing only for a brief cosmic moment before fading away. This could mean that puffy supergiants are rare because they are temporary. They might form under very specific conditions, exist in an unstable state for only a few 100,000 years, and then quickly transition into something else. If this is true, then it would explain why we don't see many of them. Most stars don't go through this phase, and the ones that do don't stay in it for long. But there's still one final, mind-bending possibility. What if some of these stars aren't dying at all? What if they are actually being rejuvenated by some unknown process? Some astronomers have proposed that certain types of massive stars could gain mass instead of losing it, either by absorbing material from a companion star or by accreting gas from their surroundings. If this is happening with Puffy supergiants, then some of them might not be in their final stages. They could actually be getting bigger and more massive over time. This would make them some of the most extreme objects in the universe, not just unstable giants, but stars that are actively defying the normal rules of stellar evolution. Instead of burning out and collapsing, they might be feeding on surrounding gas, growing larger and more bloated, becoming even more unstable as they continue to expand. If this is happening, then we might be witnessing a completely new type of stellar evolution, one where stars don't simply follow a predetermined path, but instead exist in a constantly changing state, adapting to their environment in ways we never imagined. And if that's true, then Puffy supergiants aren't just strange anomalies. They are cosmic laboratories, revealing secrets about the fundamental nature of stars, gravity, and the very fabric of space itself. The more we study them, the more we realize that the universe is far more unpredictable than we ever thought. Every time we think we understand how stars work, objects like these come along and rewrite the rules. So what happens next? As telescopes become more powerful and technology improves, astronomers will continue to search for more of these mysterious stars. Future space missions might detect even more extreme examples, stars that are even larger, even more unstable, and possibly even on the verge of collapsing before our eyes. If we can catch one of these stars in the act of disappearing, it could provide the ultimate proof that some of them are turning into black holes without supernovae. And if that happens, then everything we thought we knew about the life and death of stars will have to be reconsidered. The universe is filled with surprises, and Puffy supergiants might be one of the biggest ones yet. They challenge our theories, break the rules of stellar evolution, and force us to rethink the very nature of how stars form and die. But perhaps the biggest mystery of all is this: if these stars are so unstable, so chaotic, and so unpredictable, then how many of them are already gone? How many Puffy supergiants have already vanished into black holes, leaving no trace behind? And how many more are out there, waiting to reveal their secrets before they disappear forever? The answers might be out there, hidden among the stars, waiting for us to find them. But one thing is certain: whatever the truth about Puffy supergiants may be, it will change our understanding of the universe forever. If Puffy supergiants are the missing link in stellar evolution, then their existence forces us to question not only how stars die but also how they are born in the first place. These stars don't just appear out of nowhere. Something must create them, and that something must be extraordinary. Scientists have long suspected that extreme stellar environments, such as dense star-forming regions or areas with intense radiation, could give rise to such unusual objects. But the exact process remains unknown. Could these stars be the result of mergers between other massive stars? Or are they the product of a completely different type of stellar formation that we have yet to fully understand? One of the most compelling theories suggests that Puffy supergiants might be created from the remnants of previous supernovae. When a massive star explodes, it leaves behind a dense core, either a neutron star or a black hole, surrounded by expanding layers of gas. In some cases, this gas could collapse back onto itself, forming a new, highly unstable star. If this happens, then Puffy supergiants could be a sort of second-generation massive star, formed not from a regular stellar nursery but from the explosive aftermath of another star's death. This idea is particularly fascinating because it suggests that these stars might be some of the most extreme objects in the universe, not just because of their size and instability, but because they could be fundamentally different from other stars. If a Puffy supergiant is born from the remnants of a supernova, then it might contain unusual chemical elements, strange internal structures, or even exotic forms of matter that don't exist inside normal stars. But if these stars are so unstable, how do they manage to exist at all? The answer might lie in their strange atmospheres. Unlike typical supergiants, which have relatively dense outer layers, puffy supergiants have atmospheres that are so extended and diffuse that they resemble planetary nebulae more than regular stars. In fact, some scientists believe that these stars might not have traditional atmospheres at all. Instead, they could be surrounded by massive clouds of plasma, constantly shifting and changing shape. This could explain why some of these stars appear to flicker in brightness. Instead of pulsating like normal variable stars, puffy supergiants might be surrounded by swirling clouds of hot gas that periodically block their light. This could make them appear to change in size or brightness without actually undergoing physical changes. If this is true, then our observations of these stars could be misleading. We might not be seeing the star itself, but rather the chaotic movement of its surrounding gas clouds. And that raises another question: are puffy supergiants really stars at all? Or are they something else entirely? Perhaps a previously unknown phase of stellar evolution, or even a new type of astrophysical object? Some researchers have even proposed that these stars could be a form of failed supernova, where a massive star begins to explode but then somehow collapses back into itself before the explosion is complete. If this happens, then puffy supergiants could be the missing link between normal supergiants and black holes. But what about their ultimate fate? If these stars are so unstable, then it's likely that they don't last long. Some might collapse directly into black holes, while others might undergo violent outbursts, shedding their outer layers in massive eruptions before finally fading away. In some cases, they might even leave behind unusual remnants, dense objects that aren't quite neutron stars or black holes, but something in between. And this brings us to one of the most intriguing possibilities of all. Could puffy supergiants be connected to some of the universe's most mysterious cosmic phenomena? Some scientists believe that these stars might be responsible for certain types of gamma-ray bursts, the most powerful explosions in the universe. If a puffy supergiant collapses in just the right way, it could release an immense burst of energy, sending shockwaves across space and potentially even altering the course of nearby galaxies. If this is true, then studying these stars isn't just about understanding their nature, it's about uncovering the hidden forces that shape the cosmos itself. They might hold the key to some of the most important mysteries in astrophysics, from the origins of black holes to the nature of dark matter and dark energy. But perhaps the most haunting question is this: how many of these stars are out there, silently waiting to collapse? If some of them are already in the process of disappearing, then we might be witnessing the last moments of an entire class of celestial objects. And if that's the case, then time is running out to study them before they vanish forever. The more we learn about puffy supergiants, the more they challenge our understanding of the universe. They are not just massive, unstable stars. They are cosmic enigmas, defying the rules of stellar evolution and forcing us to reconsider everything we thought we knew about the life and death of stars. And as new telescopes come online and new discoveries are made, we may finally start to unravel their secrets. But until then, these strange, bloated stars remain one of the greatest unsolved mysteries of space. Puffy supergiants are not just an anomaly in stellar evolution. They are a direct challenge to the way we categorize and understand stars. Their very existence raises an unsettling question: how many other stars out there defy our understanding in ways we have yet to recognize? For decades, astronomers have classified stars based on their mass, temperature, and brightness, fitting them neatly into categories like main sequence stars, red giants, white dwarfs, and supernova progenitors. But puffy supergiants refuse to conform. Their massive, bloated atmospheres defy expectations, and their lifespans, though short by cosmic standards, are still long enough to leave scientists baffled about what holds them together. One of the biggest challenges in studying these stars is their unpredictable nature. Unlike stable stars that follow a relatively predictable evolutionary path, puffy supergiants seem to teeter on the edge of chaos. Their enormous outer layers can be shed in massive outbursts, potentially changing their appearance dramatically in just a matter of years or even months. This is unlike anything seen in other massive stars, which usually take thousands or millions of years to undergo significant changes. And then there's the issue of their internal structure. Most stars have well-defined layers, with a hot, dense core surrounded by progressively cooler outer shells. But puffy supergiants might not have such clear distinctions. Some models suggest that their interiors could be highly turbulent, with convection currents and shock waves constantly reshuffling material in ways that prevent the formation of stable layers. If true, this would make them some of the most dynamically unstable objects in existence, essentially massive, boiling spheres of plasma on the verge of self-destruction. This could also explain why their atmospheres appear so extended. If the core of a puffy supergiant is in a state of constant upheaval, then its outer layers could be inflated by intense waves of energy pushing outward. But this also raises another mystery. Why don't these stars just explode outright? If they're so unstable, why do they linger for thousands or even millions of years before finally collapsing? Some researchers suspect that they might be held together by an unknown mechanism, something beyond the standard forces that govern stellar stability. One possibility is that puffy supergiants could be partially supported by radiation pressure. In most stars, the outward pressure from radiation generated by nuclear fusion is balanced by the inward pull of gravity, keeping the star in equilibrium. But in these bloated giants, the balance might be precarious. If radiation pressure is unusually strong, it could be inflating the star to an extreme size, holding it together just enough to delay its inevitable collapse. Another possibility is that these stars are being influenced by unseen forces, such as powerful magnetic fields. Some of the most extreme stars in the universe, like magnetars, are known to have magnetic fields billions of times stronger than Earth's. If puffy supergiants possess similarly intense magnetic fields, it could be affecting their internal structure in ways that make them behave differently from normal stars. But perhaps the most mind-bending theory is that these stars are interacting with dark matter. Dark matter is one of the biggest mysteries in astrophysics, an invisible substance that makes up most of the universe's mass but has never been directly detected. Some scientists have proposed that certain types of stars could capture dark matter particles, which could then interact with normal matter in strange ways. If puffy supergiants are somehow accumulating dark matter in their cores, it could be affecting their stability, making them behave in ways that seem impossible according to standard physics. And if that's true, then studying these stars could provide clues about one of the greatest unsolved mysteries of all: what is dark matter? Could it be more than just an invisible gravitational force? Could it play a role in shaping the life and death of stars in ways we never imagined? But beyond these theoretical possibilities, there's still the practical question of how many of these stars exist. Are they rare cosmic oddities, or are they actually common but simply difficult to detect? Some astronomers believe that many massive stars might go through a puffy supergiant phase but remain hidden from view because of their extreme brightness variations or surrounding gas clouds. If that's the case, then our current models of stellar evolution might need to be completely rewritten. And that leads to another disturbing thought. If puffy supergiants are more common than we realize, then they could play a major role in shaping the universe. Their eruptions could seed galaxies with heavy elements, influencing the formation of new stars and planets. Their collapses could generate powerful gravitational waves, rippling across space-time in ways that could be detected by future observatories. And if they are indeed linked to gamma-ray bursts, then they could be among the most violent objects in existence, capable of unleashing cosmic explosions that could sterilize entire regions of space. But perhaps the biggest mystery of all is what happens to them in their final moments. Do they collapse quietly into black holes, vanishing without a trace? Do they explode in supernovae more powerful than anything we've seen? Or do they undergo an even stranger fate, one that we have yet to even imagine? Some theorists have proposed that puffy supergiants might not follow the typical supernova path at all. Instead, they could undergo a process known as direct collapse, where the entire star implodes so rapidly that it bypasses the supernova stage entirely, forming a black hole in an instant. If this happens, then they could be responsible for some of the largest black holes in the universe, objects so massive that they challenge our understanding of how black holes form. And if that's the case, then these stars might be hiding in plain sight. Instead of fading away gradually, They could be vanishing instantly, leaving behind black holes that are impossible to distinguish from those formed by other means. This could mean that some of the supermassive black holes we see in distant galaxies were once puffy supergiants, their brief but dramatic lives ending in total annihilation. The more we study these strange, bloated stars, the more questions we uncover. They are not just another type of supergiant, they are a cosmic puzzle, defying the laws of physics and hinting at forces we have yet to understand. They challenge our assumptions about how stars evolve, how they die, and what happens to them afterward. They may even hold the key to some of the deepest mysteries of the universe, from the nature of dark matter to the origins of the most powerful explosions in existence. And as telescopes grow more advanced, we may finally start to get answers. New observatories like the James Webb Space Telescope and upcoming next-generation space telescopes will allow us to peer deeper into the cosmos than ever before, potentially revealing new insights into these enigmatic objects. But until then, puffy supergiants remain one of the greatest unsolved mysteries of space. Massive, unstable, and defying explanation, they are a reminder that the universe is far more complex and mysterious than we ever imagined. Puffy supergiants defy expectations at every turn. They don't behave like other massive stars, they don't evolve in predictable ways, and they seem to push the limits of what a star can even be. Their sheer size alone is enough to make them an outlier, but it's the deeper mysteries, their internal structure, their erratic lifespans, their possible connection to dark matter, that make them one of the most fascinating enigmas in astrophysics. To truly understand why these stars are so baffling, we need to compare them to other known types of supergiants. Typical red supergiants, like Betelgeuse, are enormous but relatively well understood. Their outer layers expand as their cores burn through fuel, causing them to swell up to hundreds or even thousands of times the size of the Sun. But despite their size, they maintain a level of predictability. When their fuel runs out, they explode in a supernova, leaving behind either a neutron star or a black hole. Puffy supergiants, on the other hand, seem to exist in a category of their own. They don't just expand in size. They balloon outward to an extreme degree, forming atmospheres so loose and diffuse that they appear almost like cosmic ghosts. This is what makes them so hard to detect. Their outer layers are so thin and spread out that, in some cases, they barely emit visible light. Instead, much of their radiation is lost in the infrared or even radio wavelengths, making them nearly invisible to traditional telescopes. One of the biggest questions surrounding these stars is how long they last. The answer to that depends on what's actually happening inside them. Some scientists believe that the puffy supergiant phase is extremely short-lived, perhaps only lasting a few 100,000 years, or even less. This would make them some of the rarest stars in the universe, existing only as fleeting anomalies before collapsing or transforming into something else. But others argue that these stars could be much more stable than we think. If their extreme size is caused by an unusual balance of forces, perhaps involving radiation pressure or magnetic fields, then they could exist for millions of years, slowly evolving in ways that we have yet to fully understand. If that's the case, then we may have underestimated how many of these stars are out there. Another mystery is how they lose mass. Normal supergiants shed their outer layers through stellar winds, powerful streams of gas driven by intense radiation. But puffy supergiants may be losing mass in ways that are completely different from any other type of star. Some observations suggest that they undergo sudden, violent eruptions, where huge amounts of material are ejected all at once, rather than being steadily lost over time. If true, this could mean that these stars are even more unstable than previously thought, existing in a delicate state of near collapse. But perhaps the biggest puzzle is what happens when they reach the end of their lives. Most stars in their mass range are expected to explode as supernovae, leaving behind neutron stars or black holes. However, if the puffy supergiant phase is truly unique, then it's possible that these stars don't follow the normal rules of stellar death. Some researchers have proposed that they could undergo direct collapse, imploding so quickly that they skip the supernova stage entirely, forming black holes in an instant. If that's the case, then we may have already seen the results without realizing it. There are many black holes in the universe that seem too massive to have formed from regular supernovae. Some of these may have been created by Puffy supergiants collapsing directly, their massive, unstable atmospheres vanishing in a sudden, catastrophic implosion. But what if there's something even stranger happening? Some theoretical models suggest that Puffy supergiants could be linked to an even more exotic phenomenon, failed supernovae. These are events where a massive star reaches the end of its life, but instead of exploding outward, it simply fades away, its outer layers quietly falling into its core as it turns into a black hole. If Puffy supergiants follow this path, then they could be responsible for some of the most mysterious disappearances in the cosmos, stars that seem to vanish without a trace, leaving no visible explosion behind. And then there's the possibility that these stars are doing something that completely defies current physics. Could they be connected to dark energy, the mysterious force that's accelerating the expansion of the universe? Could they be generating exotic particles that we have yet to discover? Could they be revealing new laws of physics that go beyond what we currently understand? The more we study them, the more questions arise. And yet, despite all of this uncertainty, one thing is clear: Puffy supergiants are not just another type of massive star. They are something far more unusual, perhaps even something we have yet to fully define. They challenge our understanding of stellar evolution, they push the limits of what we think is possible, and they hint at forces that may reshape the way we see the cosmos. With new telescopes coming online in the next few years, we may finally begin to unravel their secrets. But until then, they remain one of the greatest cosmic mysteries, a reminder that, no matter how much we think we know about the universe, there are always new surprises waiting just beyond the edge of our understanding. Puffy supergiants are more than just an anomaly. They are a direct challenge to everything we assume about how stars work. Their existence forces us to rethink the very mechanics of stellar evolution, the balance between gravity and radiation, and the ultimate fate of the most massive objects in the universe. These stars are so incomprehensibly large that if one replaced our Sun, its outer layers would stretch beyond the orbit of Jupiter, yet their atmospheres are so diffuse that they almost seem to be more like nebulas than traditional stars. And that's where the confusion deepens. How can a star be so massive yet so loosely bound? What prevents it from either collapsing inward or blowing itself apart entirely? If these objects exist in a state that is neither stable nor collapsing, then what unknown forces are at play? One theory suggests that the extreme puffiness of these stars is due to intense radiation pressure. In a normal star, gravity pulls inward while the pressure generated by nuclear fusion pushes outward, creating a balance that keeps the star intact. But in a Puffy supergiant, the outward force seems to be much stronger than expected, causing the star's outer layers to drift far beyond what conventional models predict. This suggests that something unique is happening deep within their cores, perhaps an unusual type of fusion, an unexpected interaction between particles, or even a process that we have yet to discover. Some researchers believe that these stars could be tapping into unknown sources of energy, possibly involving exotic states of matter or interactions with dark matter particles that influence their structure in ways that ordinary physics cannot explain. If true, then these stars could be laboratories for studying the most mysterious forces in the cosmos. The more we study them, the stranger they seem. Unlike other massive stars that lose mass gradually through solar winds, Puffy supergiants appear to shed their material in sudden, unpredictable bursts. Some scientists suspect that their outer layers may not be held together in a traditional way but are instead in a constant state of flux, with matter continuously escaping and reforming in ways that do not match any other known celestial object. This raises an even deeper question: are these stars actually stars at all, or are they something entirely different? Could they represent an in-between stage of stellar evolution, a bridge between normal stars and something more exotic? If that's the case, then we may have overlooked an entire category of astrophysical phenomena, one that challenges the very nature of how we define a star. Another baffling feature of these objects is their temperature distribution. Most stars have a clear gradient, with the core being the hottest and the outer layers gradually cooling as they extend outward. But observations of Puffy supergiants suggest something strange. Some of their outer layers appear to be significantly hotter than expected, almost as if they are generating heat independently rather than simply radiating energy from the core. This is completely counterintuitive because, in a traditional star, heat flows outward from the center. If the outer layers of Puffy supergiants are somehow producing additional energy, then that could point to an entirely new process at work, perhaps some kind of exotic nuclear reaction or a previously unknown interaction between stellar material and cosmic radiation. Even more mysterious is their lifespan. If these stars are as unstable as they appear, then they should not last very long, perhaps only a few 100,000 years at most. But some evidence suggests that they may be much older than expected, potentially surviving for millions or even tens of millions of years. If true, then that means they must have some mechanism for maintaining their bizarre structure over vast stretches of time. Some scientists have speculated that they might be periodically resetting themselves, collapsing slightly before expanding outward again in cycles that we have yet to understand. This would make them one of the first known examples of a star that continuously oscillates between states rather than following a straightforward evolutionary path. But perhaps the most mind-bending possibility is that Puffy supergiants are not just unusual stars but rather indicators of a deeper cosmic mystery, one that could fundamentally alter our understanding of the universe itself. Some researchers have suggested that their strange properties might be linked to the effects of dark energy, the mysterious force driving the expansion of the universe. If these stars are somehow interacting with dark energy in a way that affects their structure, then they could be providing a crucial missing piece in one of the biggest puzzles in modern physics. Could it be that Puffy supergiants are acting as natural laboratories for testing the influence of dark energy on normal matter? If so, then they might not just be rare, exotic stars. They might be the key to unlocking a new understanding of how the universe operates on the largest scales. And yet, for all our speculation, the truth is that we still don't fully understand what these objects are. They remain on the fringes of astrophysical research, difficult to detect and even harder to study in detail. But with upcoming telescopes and advancements in observational techniques, we may soon be able to gather the data we need to finally unravel their mysteries. What we find could change our understanding of stars, of gravity, of energy, and perhaps even of the fundamental laws that govern the cosmos. For now, though, they remain one of the most tantalizing enigmas in space, massive, ephemeral, and utterly unlike anything else we have ever seen. If Puffy supergiants truly challenge the conventional understanding of stars, then the key to unlocking their mysteries may lie in their formation. How do these enormous, loosely bound objects come into existence in the first place? Are they born this way, or do they evolve from other types of massive stars? The standard model of star formation suggests that gas and dust collapse under gravity, gradually heating up until nuclear fusion ignites. But for a star to become a Puffy supergiant, something unusual must happen during this process, something that allows it to expand far beyond what normal physics would predict. One possibility is that they start as ordinary massive stars but experience an unusual phase of extreme expansion due to a temporary imbalance between radiation pressure and gravity. This could be triggered by an unexpected burst of energy from deep within the core, possibly due to an alternative form of nuclear fusion, or even a sudden release of exotic particles. If such an event were powerful enough, it could push the outer layers outward, creating the extraordinarily diffuse structure that defines a Puffy supergiant. But if this explanation were correct, then these stars should be relatively short-lived, eventually collapsing back into a more stable form or shedding their outer layers entirely. However, some evidence suggests that these stars remain in their puffy state for much longer than expected, raising the possibility that they have found a way to sustain their unusual structure for millions of years. Another theory suggests that Puffy supergiants could be the result of stellar mergers, collisions between two or more massive stars that create an object so unstable that it rapidly expands to enormous proportions. When two massive stars collide, their combined energy output can be extreme, potentially leading to an expanded outer atmosphere that remains in a delicate balance between expansion and gravitational collapse. If this were the case, then Puffy supergiants might actually be far more common than we realize, simply because most of them eventually shrink back down or explode before we have the chance to observe them in their expanded state. Yet another possibility is that these stars form in regions of space where conditions are vastly different from what we are used to, perhaps in environments with unusual magnetic fields, extremely low-density interstellar gas, or even unknown forms of cosmic radiation that influence their development in ways we do not yet understand. Some researchers have speculated that certain parts of the universe may contain unique conditions that allow for the creation of these bizarre stars, meaning that they may be far more prevalent in some galaxies than in others. But if their formation is a mystery, then their ultimate fate is even more puzzling. What happens when a Puffy supergiant reaches the end of its life? Do they collapse into black holes like other massive stars? Or do they follow an entirely different path? If their extreme puffiness is due to an unknown force counteracting gravity, then what happens when that force is no longer able to hold them together? Some scientists believe that these stars could undergo a form of silent collapse, where instead of exploding in a dramatic supernova, they simply implode, leaving behind only a black hole with no visible explosion. If this were the case, then it could explain why certain regions of space seem to contain more black holes than expected. Perhaps many of them were once puffy supergiants that disappeared without a trace. Others suggest that their diffuse outer layers could make them prone to a different kind of stellar death, one where the star slowly evaporates rather than collapsing outright. If a puffy supergiant is losing mass at an extreme rate through unpredictable bursts, then it could gradually fade away over time, shedding layer after layer until nothing remains. If this theory is correct, then some of the faintest, most mysterious objects in space could be the remnants of former puffy supergiants that have been stripped down to their cores, leaving behind only faint embers of what was once a massive, enigmatic star. But perhaps the most intriguing theory is that some of these stars may not die at all, at least not in the way we expect. If they are connected to unknown physical processes, then it's possible that instead of collapsing into black holes, they could transition into something even more exotic. Could they become strange, ultra-low-density neutron stars? Could they be the precursors to entirely new classes of celestial objects that we have yet to discover? If so, then puffy supergiants may not just be a rare type of star. They may be a missing link in a completely unknown branch of stellar evolution, pointing us toward new physics that goes beyond our current understanding. With all of these unanswered questions, it's no surprise that puffy supergiants have become one of the most compelling mysteries in astrophysics. But despite the uncertainty, one thing is clear: these stars challenge the very foundations of what we think we know about the universe. They force us to reconsider everything from stellar physics to dark energy, from the nature of gravity to the limits of observable matter. Every new observation raises more questions than answers, and yet, that is precisely what makes them so fascinating. The quest to understand puffy supergiants is just beginning, and as new telescopes and observational technologies come online, we may finally get the data we need to solve their mysteries. But until then, they remain an enigma, giant, ghostly, and utterly unlike anything else in the cosmos. They remind us that the universe is far stranger than we ever imagined, and that even the most fundamental questions, like what a star really is, may still have answers waiting to be discovered. If puffy supergiants are truly as rare and enigmatic as they seem, then one of the biggest challenges in studying them is simply finding more of them. These stars are so massive and yet so diffuse that their outer layers blend seamlessly into the surrounding space, making them incredibly difficult to detect. Their low surface gravity means that much of their light is scattered rather than emitted in a concentrated way, further complicating efforts to pinpoint their exact locations. Unlike other massive stars, which burn brightly in predictable patterns, puffy supergiants can appear faint and ghostly, often mistaken for background nebulas or distant, unresolved star clusters. Astronomers searching for these objects must rely on indirect methods, measuring spectral shifts, tracking unexpected fluctuations in brightness, and analyzing anomalous data from infrared and ultraviolet surveys. In some cases, these stars only become visible when they undergo sudden changes, such as an unexpected outburst of mass loss or an interaction with a nearby stellar companion. Even then, distinguishing them from other types of variable stars is difficult, since their unique properties do not fit neatly into any known classification. Some researchers suspect that we may have already observed many more Puffy supergiants than we realize, but failed to identify them as such due to the limitations of our current models. This raises an even bigger question. If these stars are so difficult to find, how many of them are actually out there? Are they truly rare, or have we simply overlooked them due to their unusual properties? If we could develop better techniques for identifying them, would we suddenly discover that they are far more common than previously thought? Some astronomers believe that future space telescopes, particularly those equipped with advanced spectroscopic capabilities, may be able to detect subtle signatures unique to these stars, perhaps certain absorption lines in their spectra or distinctive fluctuations in their luminosity. If such methods prove successful, then we may soon find ourselves facing an entirely new population of stellar giants lurking in the shadows of the cosmos. But if these stars are more common than we assume, then another mystery arises. Why do they exist at all? If Puffy supergiants represent a stable phase of stellar evolution, then we should be able to explain their structure using known physical principles. Yet every attempt to model them results in contradictions. Their outer layers are too extended to be held together by normal gravitational forces, their temperatures are inconsistent with their luminosity, and their mass loss rates do not match any known mechanism of stellar wind production. This suggests that we are missing something crucial, some hidden variable or unknown force that allows these stars to maintain their unusual structure for extended periods. One hypothesis is that their extended atmospheres may be supported by an exotic form of turbulence, one that redistributes energy in a way that prevents collapse while also inhibiting rapid expansion. In normal stars, convection plays a major role in transporting heat from the core to the outer layers, but in Puffy supergiants, this process may work in unexpected ways, creating localized regions of high energy that keep the star puffed up. If this is true, then it could point to an entirely new type of stellar dynamics, one that does not follow the conventional rules of hydrostatic equilibrium. Another possibility is that these stars may be interacting with something beyond our current understanding of physics, perhaps an unknown form of cosmic radiation, exotic particles, or even the influence of dark matter. Some researchers have speculated that if these stars exist in regions of space with unusually high concentrations of dark matter, then interactions between dark matter particles and normal stellar material could create effects that we have never observed before. Could it be that Puffy supergiants are, in some sense, powered by interactions with the unseen matter that makes up most of the universe? If so, then studying them could provide one of the first tangible clues about the nature of dark matter itself. And yet, for all these theories, we still lack definitive proof of what keeps these stars from collapsing. The very fact that they exist suggests that our understanding of stellar physics is incomplete, that there are forces at play in the universe that we have yet to fully grasp. The more we learn about them, the more questions arise. Are they a brief, transitory phase in the life cycle of massive stars, or are they a distinct and long-lived category of their own? Do they eventually shrink down into more conventional supergiants, or do they end their lives in ways we have never seen before? Perhaps the most tantalizing idea is that Puffy supergiants are not just an anomaly but a clue to a larger, hidden structure in the universe, one that links the evolution of stars to deeper cosmic forces that we have only begun to explore. Could these stars be remnants of an earlier era in the universe's history, when the conditions for star formation were different from what we see today? Could they be evidence of new physical laws that only manifest under extreme conditions? If so, then their discovery could be one of the most important breakthroughs in modern astrophysics. For now, we are left with more questions than answers. But one thing is certain: Puffy supergiants are a mystery worth solving. They defy our expectations, challenge our theories, and hint at new possibilities that stretch the boundaries of what we know. As we continue to study them, we may find ourselves not just uncovering the secrets of these strange, bloated stars but also unlocking deeper truths about the universe itself. The more we study Puffy supergiants, the clearer it becomes that these stars are unlike anything else in the universe. Their sheer size and structure defy what we thought was possible for stellar physics, and every new observation raises more questions than answers. But perhaps the biggest question of all is this: What if these stars are not just rare but are actually a sign of something much bigger happening in the universe? Some scientists speculate that the existence of Puffy supergiants could point to a fundamental shift in how we understand stellar evolution. Traditionally, stars follow a well-documented life cycle. They form, burn fuel, expand, and either collapse or explode. But Puffy supergiants don't seem to fit into any of these categories in the way we expect. They are too large, too diffuse, and seem to exist in a state of precarious balance that shouldn't be sustainable for as long as they appear to last. What if we are witnessing a completely new stage of stellar life? One that only happens under very specific cosmic conditions. One of the more radical theories is that Puffy supergiants might be a sign that some stars are aging in an entirely different way than we thought. Instead of gradually running out of fuel and collapsing inward, perhaps some stars experience a late-stage phenomenon that causes them to expand to extreme sizes, making them appear far larger than their actual mass would suggest. This could be due to unexpected fusion reactions deep inside the star, strange interactions with external forces, or even unknown quantum effects that change the way matter behaves under extreme pressure. If this is true, then Puffy supergiants could be a missing link in our understanding of how stars evolve. They might represent a phase that only happens under certain conditions, perhaps when a star reaches a critical point where normal gravitational forces can no longer contain the energy being generated within. Instead of exploding in a traditional supernova, the star might enter a prolonged period of instability, growing larger and less dense as it struggles to maintain equilibrium. This could mean that we have been overlooking an entire class of stellar transformations that have been happening right under our noses. But there's another possibility, one that's even more unsettling. What if these stars aren't just evolving differently but are actually being affected by something we don't understand? Could there be an external force at work, altering the physics of certain stars in ways we cannot yet detect? Some researchers have speculated that these stars might be interacting with unknown cosmic phenomena, perhaps distortions in spacetime, remnants of ancient black holes, or even regions of space where the fundamental laws of physics behave differently. There is a growing body of evidence suggesting that certain parts of the universe may contain anomalous zones, where stars and galaxies behave in ways that cannot be explained by our current understanding of physics. These zones could be influenced by exotic particles, variations in the distribution of dark matter, or even effects related to higher dimensional space. If Puffy supergiants tend to form in these regions, it might mean that they are not just rare cosmic oddities but rather a direct clue to larger, unseen forces shaping the cosmos. Another fascinating idea is that Puffy supergiants could be remnants of an earlier era of star formation, perhaps even leftovers from the very first generation of stars in the universe. If these stars are composed of unusual elements or formed under conditions different from those found in modern galaxies, then they could represent an entirely separate lineage of stellar evolution. This would mean that Puffy supergiants are not just rare but are actually ancient, surviving relics of a time when the universe itself was structured differently. One way to test this hypothesis would be to study the chemical composition of these stars in greater detail. If they contain unexpected elements or isotopic ratios that do not match those of more typical stars, it could provide strong evidence that they formed under conditions unlike anything we see today. This would also raise even deeper questions about how stars form and evolve, suggesting that the rules governing stellar life cycles may be more flexible than we ever imagined. Yet even if Puffy supergiants turn out to be a rare and temporary phase of stellar evolution, their existence still forces us to reconsider everything we thought we knew about how stars work. How can a star remain so large and diffuse without simply tearing itself apart? What mechanisms allow it to sustain its shape for as long as it does? And if these stars are capable of maintaining such extreme sizes, could there be even larger, even stranger objects out there that we have yet to discover? Some researchers have even begun to wonder whether Puffy supergiants could be the precursors to entirely new types of celestial bodies, perhaps objects that exist on the boundary between stars and something else entirely. If a Puffy supergiant were to collapse in a way that doesn't produce a traditional supernova, could it instead form an object we have never seen before? Could these stars be the missing link between ordinary supergiants and more exotic entities like magnetars, strange quark stars, or even primordial black holes? The idea that there are still fundamental mysteries about the life cycle of stars is both thrilling and humbling. We often assume that we have already figured out the basic rules of how the universe works, but objects like Puffy Supergiants remind us that we are still just scratching the surface. Every time we think we have a complete model of stellar physics, new discoveries force us to go back to the drawing board, revising our theories and expanding our understanding of what is possible. As telescopes grow more powerful and our ability to observe distant parts of the universe improves, we may soon be able to answer some of the questions surrounding these strange stars. But for now, they remain one of the greatest enigmas of modern astrophysics, a mystery wrapped in glowing clouds of cosmic dust, hidden at the edges of our understanding. They challenge us to look deeper, to think bigger, and to accept that the universe is far stranger than we ever imagined. If Puffy supergiants are more than just an unusual phase of stellar evolution, then we might be looking at one of the biggest gaps in our understanding of astrophysics. These stars shouldn't exist in the way they do, not for the time frames we observe, not with the structures they have, and not in the conditions they appear to thrive in. But they do exist, and that alone means our models of stellar life cycles need serious adjustments. One of the strangest aspects of Puffy supergiants is how they manage to maintain their enormous, almost ethereal structure. Normally, a star's balance is maintained through hydrostatic equilibrium, a constant battle between gravity pulling inward and radiation pressure pushing outward. But in these stars, that balance seems almost exaggerated, stretched to its limits. The outer layers of a Puffy supergiant appear so loosely bound that they seem barely connected to the core, almost like a massive, luminous cloud that just happens to be shaped like a star. How is this possible? Some researchers believe that these stars must be experiencing an incredibly delicate, yet powerful, form of radiation pressure, one that keeps them from collapsing while simultaneously preventing them from dispersing into space. If this is true, then Puffy supergiants might be operating under conditions that push the known limits of nuclear fusion. This could mean that their energy output is so extreme that their own gravity is barely strong enough to hold them together. Essentially, they are in a constant state of near destruction, surviving only because of a delicate balance that, at any moment, could tip out of control. But this raises an even bigger question: what happens when that balance is lost? Do these stars suddenly collapse in on themselves, forming black holes or neutron stars in a way that bypasses the traditional supernova stage? Or do they expand even further before fading into a more diffuse state, perhaps turning into massive planetary nebulae that are unlike anything we've seen before? There is also speculation that Puffy supergiants might be the end result of extreme stellar mergers. If two or more massive stars collide under just the right conditions, they might briefly combine into a single, oversized structure before settling into a more stable form. This could explain why these stars appear so unstable. If they are essentially recovering from a recent merger, then they might be going through an extended period of adjustment, trying to find a new equilibrium. But here's the truly mind-bending part. If Puffy supergiants are the remnants of stellar mergers, then what happens when they eventually collapse? Could they form objects even more exotic than black holes or neutron stars? Some theoretical models suggest that extremely massive, diffuse stars could create something entirely different upon their death, perhaps even leading to the formation of exotic ultra-dense matter states that we have never observed before. And then there's the possibility that Puffy supergiants are not just extreme versions of ordinary stars but are actually something else entirely. Could they be failed galaxies? Collections of gas and dust that were once on the verge of forming into a small galaxy but instead collapsed into a single, oversized star? Could they be the product of interactions with dark matter, with their unusual structure being influenced by forces we cannot yet detect? Some astronomers even speculate that these stars could be linked to early universe conditions, forming in environments that no longer exist in the modern cosmos. If this is the case, then studying them could give us direct insight into how the first stars in the universe might have behaved, revealing details about the conditions that existed shortly after the Big Bang. And if Puffy supergiants are indeed relics of an earlier time, then what does that say about the nature of the universe itself? Could these stars be living proof that cosmic evolution happens in ways we still don't fully understand? Could they be hints that there were once even stranger types of stars that have since disappeared, leaving only a few rare examples behind as evidence of their existence? There is so much about Puffy supergiants that remains unknown, and that is what makes them one of the most fascinating mysteries in modern astrophysics. Every observation, every piece of data we collect, brings us closer to understanding them, but for now, they remain an enigma. Are they a rare phase of stellar evolution, or do they represent an entirely new class of celestial objects? Are they the result of natural cosmic processes, or are they influenced by forces we have yet to discover? Whatever the answer is, one thing is clear: Puffy supergiants challenge our understanding of the universe in ways that few other phenomena do. They force us to rethink what we know about stars, about gravity, and even about the very nature of space itself. And until we uncover their secrets, they will continue to stand as one of the greatest mysteries of the cosmos. If Puffy supergiants represent a new or misunderstood phase of stellar evolution, then our current models of how stars live and die need to be seriously reconsidered. The problem is that these stars don't fit into any known category perfectly. They are not standard supergiants, because their density is far too low. They are not ordinary red giants, because their structure is vastly different. And they are certainly not protostars, since they have already gone through sustained fusion. So what exactly are they? One of the most intriguing possibilities is that Puffy supergiants might be in the middle of a process that is incredibly rare, something we don't normally get to witness in real time. Perhaps these stars are caught in a state of extreme transformation, shifting from one type of celestial body into another. This would explain why they seem so delicate and unstable, as if they are in the middle of a cosmic metamorphosis. If this is true, then studying these stars could give us a direct look at how the universe changes over time. They might be the missing link between known stellar types, showing us the exact moment when a star transitions from one state to another. But this raises an even bigger question: what are they turning into? Are they collapsing into an entirely new type of neutron star, one that is different from anything we've catalogued? Are they forming exotic white dwarfs with properties we haven't yet discovered? Or could they be in the earliest stages of becoming something else entirely, an object we have yet to classify? One idea that has been proposed is that Puffy supergiants might actually be the ancestors of magnetars. Magnetars are neutron stars with incredibly powerful magnetic fields, far stronger than anything we see in normal stars. But where do these extreme objects come from? Could it be that Puffy supergiants, with their unusual density and instability, eventually collapse in such a way that creates the conditions necessary for a magnetar to form? This would mean that these stars are not just strange in their own right but are also precursors to some of the most extreme objects in the universe. If we could confirm this, it would completely change how we think about stellar death and rebirth. It would mean that magnetars are not just the result of massive star collapses but are actually part of a longer, more complex process, one that involves a phase of extreme expansion before the final collapse. But there's another possibility, one that is even more mind-bending. What if Puffy supergiants are not transitioning into magnetars but instead are forming entirely new objects that we haven't even considered yet? The universe has already shown us that strange things can exist, things like quark stars, hypothetical objects made entirely of subatomic particles called quarks. Could Puffy supergiants be the first step toward the creation of something even more exotic? If this is the case, then we might be looking at a completely new class of stellar remnants, something that exists outside of the traditional categories of white dwarfs, neutron stars, and black holes. Perhaps these objects are so rare and so short-lived that we have simply never observed them before, and Puffy supergiants are the only clue we have that they exist. The implications of this would be enormous. It would mean that we are still missing fundamental pieces of the puzzle when it comes to understanding what happens to stars at the end of their lives. It would also suggest that the universe is capable of creating things that don't fit neatly into the classifications we have built. And if that's true, then how many other cosmic objects are out there, waiting to be discovered? Another fascinating angle to consider is whether puffy supergiants are affected by forces beyond the standard four fundamental forces of nature. Normally, stars are governed by gravity, electromagnetism, and nuclear forces. But what if something else is at play? Could these stars be interacting with dark matter in a way that causes their unusual structure? Dark matter is one of the greatest mysteries of modern physics. We know it exists because we can see its effects on galaxies, but we have no idea what it actually is. If puffy supergiants are interacting with dark matter, it could mean that these stars are providing us with a rare opportunity to study something that is otherwise invisible. Maybe their unusual density and expansion are caused by interactions with particles we have never detected before. Some scientists have even proposed that certain types of dark matter might clump together inside stars, affecting how they burn and evolve. If this is happening inside puffy supergiants, it could explain why they seem to exist in such an extreme and delicate state. The presence of dark matter might be changing the way fusion occurs, creating conditions that are unlike anything we see in ordinary stars. And if dark matter is involved, then what does that mean for the future of these stars? Could they collapse in a way that is completely different from what we expect? Could they turn into dark matter-dominated remnants, objects that behave in ways we have never seen before? The idea that we might be looking at the first evidence of dark matter interacting with normal matter inside stars is both exciting and unsettling. It would mean that the effects of dark matter are not just limited to galaxies and cosmic structures but are also playing a direct role in the life cycles of individual stars. Even if dark matter is not the explanation, there is still the question of how these stars formed in the first place. If they are not a normal phase of stellar evolution, then where do they come from? Could they be remnants of an earlier cosmic age, stars that formed under different conditions than what we see today? Some astronomers have suggested that the first stars in the universe, known as population 3 stars, might have had very different properties than modern stars. If any of these ancient stars still exist, they could look very different from what we expect, and puffy supergiants might be among them. If this is true, then studying these stars could give us a direct window into the early universe, revealing details about the conditions that existed billions of years ago. But if puffy supergiants are ancient relics, then why are they still around? Most of the first-generation stars in the universe should have exploded long ago, leaving behind only black holes and neutron stars. If these stars are survivors from that era, then they must have found a way to exist for much longer than we thought possible. One possibility is that these stars are not just old but are also feeding on their surroundings in a way that allows them to sustain themselves. Maybe they are absorbing gas from interstellar space, constantly replenishing their outer layers and extending their lifespans far beyond what we thought was possible. Or maybe they are the result of some unknown cosmic event, something that happened in the past that created a new type of star we have never seen before. Could there have been a unique set of conditions, billions of years ago, that led to the formation of these giants? If so, what caused those conditions, and could they happen again? The deeper we look into the mystery of puffy supergiants, the more questions we uncover. Every possibility leads to even stranger implications, and every theory seems to suggest that we are missing something fundamental about how stars work. These are not just ordinary stars, they are anomalies, hints that the universe still has secrets we have yet to uncover. And if we can solve this mystery, it might not just change how we see stars. It could change how we see the entire universe. If puffy supergiants are remnants of an earlier cosmic age or the result of an unknown process, then their existence might force us to rethink the entire history of stellar evolution. Could it be that the life cycle of stars is far more complex than we assumed? Maybe instead of following a predictable path from main sequence to giant to collapse, some stars experience strange detours, phases that we never considered because they are so rare or short-lived. If that's the case, then our entire understanding of how the universe works needs to be updated. One of the biggest questions is how long these stars can actually survive. Are they stable enough to persist for millions of years, or are they in a brief and volatile state before they collapse into something else? The fact that they appear so expanded and diffuse suggests that they might not be able to hold themselves together for very long. If their outer layers are so loosely bound, they might be shedding mass at an enormous rate, losing huge amounts of material as their gravity struggles to keep them intact. This could mean that puffy supergiants are effectively burning themselves out at a much faster pace than normal stars. If they are losing mass rapidly, then they are probably undergoing dramatic internal changes, with their cores evolving in ways that don't match any known stellar model. But what happens when they finally run out of fuel? If they are already in such an unstable state, then their final collapse might not be like anything we've seen before. Most supergiant stars explode as supernovae when they reach the end of their lives, leaving behind either neutron stars or black holes. But what if puffy supergiants don't follow that pattern? Could their strange structure cause them to collapse differently, producing something new? Maybe they don't go supernova at all. Maybe instead of an explosive end, they undergo a quiet but extreme transformation, collapsing directly into exotic remnants without ever producing a visible explosion. This idea is particularly intriguing because it could explain certain cosmic events that have puzzled astronomers for years. There are some cases where we've detected massive stars that should have exploded but instead seem to have simply disappeared. No supernova, no visible outburst, just a massive star that suddenly vanishes from the sky. Could it be that these disappearing stars were actually puffy supergiants undergoing direct collapse? If so, then they might be creating objects that are completely outside our current understanding of stellar remnants. One possibility is that they are forming ultralight black holes that have lower mass than what traditional models predict. Normally, a star has to be extremely massive to collapse into a black hole, but if puffy supergiants have such unusual density and composition, then maybe they can form black holes under different conditions. If this is happening, then it could mean that there are far more black holes in the universe than we thought, many of them formed from these strange, puffy stars. Another possibility is that they collapse into exotic neutron stars, ones that are far less dense than normal but still incredibly massive. If this is the case, then they could be forming objects that bridge the gap between neutron stars and black holes, something that we haven't been able to classify yet. These objects might be completely invisible to traditional telescopes, existing in a state where they don't emit light in any way we can currently detect. And what if these objects are not just different in terms of mass but also in terms of physics? What if the extreme conditions inside puffy supergiants allow for the formation of states of matter we've never observed before? We already know that neutron stars contain some of the most exotic forms of matter in the universe, with particles packed so tightly that they behave in ways that defy standard physics. But what if puffy supergiants collapse into something even stranger? Could they create objects where quantum effects dominate on a scale far beyond anything we've imagined? If this is true, then studying puffy supergiants isn't just about understanding a rare type of star, it's about unlocking entirely new laws of physics. They might be the key to answering some of the biggest questions in science, from the nature of gravity to the behavior of matter at extreme densities. If we can figure out how these stars form, evolve, and die, then we might gain insights into some of the deepest mysteries of the universe. But before we can answer these questions, we need to find more of these stars. Right now, puffy supergiants are incredibly rare, so rare that we barely have enough data to draw firm conclusions. If we could identify more of them, especially at different stages of their evolution, then we could start piecing together the bigger picture. One of the best ways to do this is through space telescopes that specialize in detecting unusual stellar structures. Instruments like the James Webb Space Telescope and future observatories could help us locate more puffy supergiants by scanning for their distinct properties. Their expanded atmospheres and unusual brightness make them stand out in certain wavelengths of light, so with the right technology, we might be able to track down dozens or even hundreds of them. And once we do, we can start testing some of the wildest theories about what they are and where they come from. We can analyze their chemical compositions to see if they contain elements that don't match standard stellar evolution. We can study their variability to determine if they are undergoing rapid internal changes. We can even look for signs that they are interacting with unknown forces, like dark matter or exotic particles. The discovery of puffy supergiants is a reminder that the universe is still full of surprises. Just when we think we've mapped out how stars work, something comes along that challenges everything we thought we knew. These stars don't fit into our existing models, and that makes them one of the most exciting mysteries in astrophysics. If we can solve this puzzle, it might not just rewrite our understanding of stars, it could change our entire perspective on how the cosmos operates. And if history has taught us anything, it's that the strangest objects in the universe often lead to the biggest discoveries. There's a reason why astronomers are so fascinated by anomalies like Puffy Supergiants. Because every time we uncover something that doesn't fit into our existing knowledge, it means there's something fundamental we've missed about how the universe works. These stars challenge our models of stellar structure, our understanding of nuclear fusion, and even the limits of what a star can become. If they are real and not just a misinterpretation of data, then they could be the key to unlocking entirely new principles of astrophysics. One of the most perplexing aspects of Puffy supergiants is how they manage to maintain their massive, swollen state. Normal supergiant stars are already incredibly large compared to regular stars, but Puffy supergiants take this to another level. Their outer layers are so extended that they appear almost ghost-like, with densities that shouldn't be able to hold themselves together. This raises the question, what force is counteracting gravity to keep these stars so expanded? One possibility is that they have an extreme form of radiation pressure. Inside a star, the energy from nuclear fusion pushes outward, balancing the inward pull of gravity. This is what keeps normal stars stable. But in the case of Puffy supergiants, that outward pressure must be enormous, far greater than anything we've seen in standard stellar models. This could suggest that they have an unusually high fusion rate, burning through their fuel at a pace that should make them highly unstable. If this is true, then these stars might be on the verge of a dramatic transformation. Perhaps they are in a temporary phase before collapsing into something even stranger. But if that were the case, we should see more of them in different stages of evolution. Instead, they seem incredibly rare, which suggests that either they don't last long, or they are hiding in plain sight, appearing as something else until their true nature is revealed. Another explanation for their extreme size could be that they are surrounded by a massive shell of material, an extended envelope of gas and plasma that makes them appear larger than they really are. If this is the case, then these stars might be shedding mass at an incredible rate, creating a kind of self-sustaining cloud around them. But that raises another question: where does all that mass go? If Puffy supergiants are constantly losing material, then they might be enriching their surrounding environments with heavy elements. This could make them a key factor in galactic evolution, contributing to the formation of new stars and even planets. In a way, they could act like cosmic furnaces, spewing out the ingredients needed for future solar systems. But if they are releasing so much material, then they should also be surrounded by vast nebulae, clouds of gas and dust that reveal their presence. Yet, we don't see many nebulae that match what we would expect from such massive mass loss. This suggests that either these stars are losing mass in a way we don't yet understand, or they are so short-lived that they don't have time to leave behind large remnants. If they only exist for a brief period before collapsing, then we might be catching them at an incredibly rare moment in their life cycle. This would make them even more mysterious because it would mean that they are constantly transitioning into something else, something we have yet to identify. One of the most exciting possibilities is that Puffy supergiants could be the missing link between regular supergiants and some of the strangest objects in the universe. For years, astronomers have speculated about the existence of stars that defy the standard models, objects that hover on the edge of stability, balancing between being a star and something entirely different. Could Puffy supergiants be these elusive in-between objects? If they are, then they might be connected to some of the most extreme phenomena we've ever observed. There are cases where astronomers have detected stars that suddenly dim for no apparent reason, only to brighten again unpredictably. Some of these events have been attributed to massive clouds of dust or unknown stellar interactions. But what if they are actually caused by Puffy supergiants going through rapid transformations? And what if their eventual fate isn't just a normal supernova or black hole collapse? What if they turn into something we've never seen before, objects that exist in a state we don't yet understand? Some theories suggest that extremely massive stars could collapse into exotic forms of matter, possibly even creating objects that exist outside the boundaries of known physics. If this is the case, then studying Puffy supergiants isn't just about understanding a rare type of star. It could be about discovering an entirely new form of stellar evolution. This could change everything we know about how stars live and die. It might even force us to rewrite our understanding of what happens when a massive star reaches the end of its life. The challenge now is to find more of these stars and study them in detail. Astronomers are already scanning the skies for unusual objects, using telescopes that can detect the faintest variations in light. If we can identify more Puffy supergiants, we might be able to track their evolution in real time, watching as they change and possibly even catching one in the act of transforming into something else. This is why space telescopes like the James Webb Space Telescope are so important. With their ability to see into the deepest parts of space, they could help us locate more of these stars and analyze their properties. By studying their light spectra, we can determine what elements they contain, how fast they are moving, and whether they are undergoing rapid changes. And if we can figure out what these stars really are, we might uncover something even bigger, a new way of understanding the universe itself. Because every time we discover something that doesn't fit, it means there's a deeper mystery waiting to be solved. Puffy supergiants might be rare, but they could be the clue that leads us to one of the greatest discoveries in astrophysics. If Puffy supergiants are more than just an anomaly, if they are a stage of stellar evolution that we've overlooked, then understanding them could reshape our models of how stars live and die. Right now, our best theories suggest that massive stars follow a predictable path. They form from collapsing clouds of gas, burn through their fuel at varying rates depending on their mass, and eventually explode as supernovae or collapse into black holes or neutron stars. But if Puffy supergiants exist as a transitional phase, they could suggest an alternative path, one where extreme stellar conditions cause a star to enter an unstable state that isn't well understood. One of the biggest challenges in studying them is that their extremely low density makes them difficult to categorize. Most stars, even massive ones, have a relatively well-defined structure, with a dense core and gradually less dense outer layers. But Puffy supergiants appear to defy this standard structure, with an outer envelope that is so extended and diffuse that it barely qualifies as a coherent star. This raises a critical question: how do these stars maintain their integrity without simply dissipating into space? One possibility is that they exist in a delicate balance between radiation pressure and gravitational pull, but this balance must be far more unstable than anything seen in conventional stars. If they are constantly on the edge of disruption, then even slight changes in their internal conditions, such as variations in nuclear fusion rates, could cause them to expand or contract unpredictably. This could explain why they are so rare. Perhaps they only exist for an extremely brief period before transitioning into something else. Another possibility is that these stars are surrounded by an extensive halo of ejected material that makes them appear larger than they actually are. If this is the case, then they could be in the final stages of their lives, shedding mass at an unprecedented rate before collapsing entirely. This might mean that Puffy supergiants are actually dying stars in disguise, objects that have exhausted their nuclear fuel and are now in a phase of rapid decay. But if that were true, then we should expect to see large amounts of expelled material surrounding them, forming nebulae or accretion disks. Yet, in many cases, such structures are absent or not as prominent as we would expect. This suggests that either these stars are shedding mass in a way that doesn't conform to standard models, or that their outer layers are held together by an unknown force. Could it be that these stars have an exotic internal structure, with a core that is somehow preventing them from collapsing despite their extreme size? Some theories propose that certain high-mass stars might undergo phases where their cores become dominated by exotic forms of matter, such as quark-gluon plasma, which could alter their stability. If this is the case, then Puffy supergiants could be more than just large stars. They could be the missing link between normal stellar evolution and something entirely new. Perhaps they represent an intermediate stage between conventional supergiants and ultra-dense objects like quark stars or magnetars. If so, then they might not simply collapse into black holes, as most high-mass stars do. Instead, they could undergo a completely different type of transformation, one that results in an object we have yet to identify. This would also explain why they are so difficult to detect. If they only exist for a short period before transitioning into something else, then we might only be able to see them at certain wavelengths of light. Some might even appear invisible to traditional optical telescopes, requiring specialized instruments to detect their presence. If so, then there could be far more of these stars than we realize, hidden among the vast number of other massive stars in the universe. One of the most intriguing possibilities is that Puffy supergiants could be precursors to the most energetic supernovae ever observed. If their internal conditions are as extreme as they seem, then their eventual collapse could result in explosions far more powerful than conventional supernovae. These events, known as hypernovae, release immense amounts of energy, potentially creating gamma-ray bursts, some of the most powerful explosions in the universe. If Puffy supergiants are indeed linked to hypernovae, then studying them could help us understand the origins of some of the most energetic cosmic phenomena. It could also provide insight into the creation of heavy elements, since these extreme explosions are believed to be responsible for producing many of the elements found in the universe today. In other words, Puffy supergiants might not just be an oddity, they could be fundamental to the chemical evolution of galaxies. But there's another possibility that's even more mind-bending. What if these stars are not simply bloated versions of normal stars, but instead represent an entirely different class of celestial object? Some astronomers have speculated about the existence of so-called dark stars, hypothetical objects that generate energy not from nuclear fusion, but from the annihilation of dark matter particles. If Puffy supergiants have an unknown energy source keeping them inflated, then they might be related to this concept, perhaps containing an unusual concentration of dark matter that influences their structure. If this is true, then Puffy supergiants could be our first observational evidence of dark matter interacting with normal matter in a way we haven't seen before. This would be a groundbreaking discovery, potentially answering one of the biggest mysteries in physics. It could also explain why these stars don't fit into existing stellar models, because they aren't following the same rules as conventional stars. At this point, the only way to truly solve the mystery is through more observations. Telescopes capable of detecting different wavelengths of light, from infrared to X-rays, could reveal details about the composition and behavior of these stars. By analyzing their spectra, we could determine whether they contain unusual elements or exhibit behaviors that suggest an alternative energy source. Ultimately, the discovery of Puffy supergiants challenges our understanding of the universe in ways we never expected. Whether they are an overlooked phase of stellar evolution, a sign of new physics, or something even stranger, one thing is certain: they demand our attention. Because every time we find something that doesn't make sense, it's a clue that there's more to the universe than we ever imagined. If Puffy supergiants truly defy the standard models of stellar evolution, then they could be a key to unlocking some of the greatest cosmic mysteries. One of the most perplexing questions in astrophysics is how stars transition from one phase to another, and whether there are intermediate stages that we have overlooked. Traditionally, we classify stars based on their mass, temperature, and luminosity, placing them into categories like main sequence stars, red giants, and supergiants. But if Puffy supergiants exist as a distinct phase, then our classification system might be incomplete. The key problem is that they don't behave like traditional stars. Their extremely diffuse structure suggests that they are held together by something other than conventional gravitational forces. If their outer layers are as spread out as they seem, then their surface gravity must be incredibly weak. This raises a critical question: what is preventing them from simply dissolving into space? One possibility is that intense radiation pressure from the core counteracts the force of gravity, but this would require an energy source far beyond what we expect from a normal fusion process. This leads to an even deeper mystery. Could Puffy supergiants be powered by an unknown mechanism? Nuclear fusion is the primary energy source for most stars, but in extreme environments, other processes might come into play. Some theories suggest that certain high-mass stars could undergo brief phases where alternative reactions, such as pair instability processes, dominate. These involve the production and annihilation of electron-positron pairs, which can lead to sudden expansions or contractions. If Puffy supergiants are experiencing something like this, then their strange appearance could be a result of temporary instability rather than a long-lasting phase. Another theory is that these stars might be in the process of merging with a companion object. In binary star systems, interactions between two stars can lead to mass transfer, where one star pulls material from the other. If a supergiant star is in the middle of such an exchange, then its outer layers might become unusually inflated, creating the appearance of a puffy supergiant. This could explain why they are so rare. Perhaps they only form under specific conditions, when two massive stars interact in just the right way. If this is true, then studying puffy supergiants could help us understand the final stages of stellar mergers, which are some of the most extreme events in the universe. Merging stars can produce gravitational waves, bursts of X-rays, and even the formation of exotic objects like magnetars or black hole binaries. If puffy supergiants are a precursor to these events, then they could be a warning sign that something even more dramatic is about to happen. But there's another possibility. What if these stars are not actually stars at all? Some astronomers have speculated that certain objects in space might mimic the appearance of stars while being something entirely different. For example, some quasars and active galactic nuclei can produce light that resembles a star, even though they are powered by supermassive black holes. If puffy supergiants are actually a new type of astrophysical object, then we might need to rethink what we consider a star. One radical idea is that these objects could be a form of failed supernova, stars that were supposed to explode but didn't quite make it. In some cases, a star's core might collapse into a neutron star or black hole, but instead of ejecting all of its outer layers, some of the material might remain in place. If this happens in just the right way, then the object could appear as an extremely bloated, unstable star. Over time, it might slowly shed its outer layers until only the collapsed core remains. If this hypothesis is correct, then puffy supergiants might be telling us something new about how stars die. Perhaps not all massive stars follow the classic pattern of explosion and collapse. Some might linger in a strange transitional state for thousands, or even millions of years. If so, then we could be looking at a completely new pathway in stellar evolution, one that challenges everything we thought we knew. The next step in solving this mystery will be to gather more data. Astronomers will need to observe these objects in multiple wavelengths, from infrared to X-rays, to understand their composition and behavior. By analyzing their spectra, we can determine whether they contain unusual elements or exhibit signs of extreme instability. Telescopes like the James Webb Space Telescope and the upcoming Extremely Large Telescope could provide the level of detail needed to finally decode what's happening inside these bizarre stars. One of the biggest unanswered questions is whether puffy supergiants are a temporary phase or a stable type of star. If they only exist for a short period, then we might have caught them in a fleeting moment of transformation, like a butterfly emerging from its cocoon. But if they can persist for millions of years, then they might be part of a previously unknown category of stars that we simply never noticed before. Regardless of what they turn out to be, one thing is certain: puffy supergiants are rewriting the rules of astrophysics. Their existence forces us to reconsider fundamental questions about how stars form, evolve, and die. If they are truly as strange as they appear, then they could be the first clue to even bigger discoveries, ones that could change our understanding of the cosmos forever. If puffy supergiants truly defy the standard models of stellar evolution, then understanding them might force us to rewrite the very foundation of astrophysics. These stars seem to operate in a realm of physics that we barely comprehend, with properties that make them stand apart from anything else in the known universe. If their bloated structures are caused by intense radiation pressure, then they must be experiencing conditions far more extreme than typical supergiants. But if their expansion is due to some kind of unknown energy source or external force, then we could be on the verge of uncovering a new mechanism of cosmic energy distribution, one that we've never encountered before. The problem with studying these enigmatic stars is that they are incredibly difficult to observe. Because they are so diffuse, their outer layers blend into the surrounding space, making it difficult to define their exact boundaries. This makes measuring their true size and mass an almost impossible challenge. If their outer atmospheres are constantly expanding and contracting due to unstable internal processes, then what we perceive as their surface might be nothing more than a constantly shifting boundary between dense and diffuse plasma. In other words, they might not have a stable surface at all, just an ever-changing, turbulent sea of ionized gas. Another major mystery is why Puffy supergiants are so rare. If they represent a fundamental phase in stellar evolution, we should expect to see many of them scattered across the cosmos. But so far, they appear to be extremely uncommon, suggesting that they only exist under very specific conditions. This could mean that they form in environments with unusual chemical compositions, perhaps in regions of space that are rich in heavy elements or subject to extreme magnetic fields. Alternatively, it could mean that they are a very short-lived phase, appearing only briefly before transitioning into something else. If the latter is true, then we might be witnessing a phenomenon that is incredibly transient, something that happens so quickly on cosmic timescales that it's almost impossible to catch in action. This would explain why our current models of stellar evolution never predicted their existence. If a normal supergiant suddenly expands into a puffy supergiant, and then just as quickly contracts back into a more stable form, then the odds of seeing one at just the right moment are incredibly slim. It's like trying to study a lightning strike by randomly taking pictures of the sky. You have to be extraordinarily lucky to capture it. This raises an intriguing question. Could puffy supergiants be linked to some of the most powerful stellar explosions in the universe? If they represent an unstable pre-supernova phase, then they could be the missing link between normal supergiants and hypernovae, the most energetic type of star explosion known. Unlike regular supernovae, hypernovae release dozens of times more energy, and can produce exotic remnants like gamma-ray bursts and magnetars. If puffy supergiants are a precursor to these events, then they could be the key to understanding what causes certain stars to explode with such extreme force. One of the most compelling theories is that puffy supergiants could be undergoing an advanced form of pulsational instability. In standard stellar models, pulsations occur when the internal pressure of a star temporarily overcomes gravity, causing the outer layers to expand outward before being pulled back in. In some cases, these pulsations can become extreme, leading to dramatic eruptions of mass and energy. If puffy supergiants are experiencing a form of runaway pulsation, then their inflated state could be the result of repeated expansions that never fully settle back down. This would explain why their outer layers are so diffuse and why they appear to be on the verge of disintegration. But what if these stars don't just fade away? What if, instead of collapsing inward, they undergo an even more violent transformation? One possibility is that puffy supergiants are actually a precursor to an entirely new type of stellar death, one that doesn't fit into the traditional categories of supernova or direct collapse. In some scenarios, a star might lose so much mass through pulsations that it eventually exposes its inner core, leading to a sudden, catastrophic collapse that bypasses the usual explosion phase altogether. If this is happening, then puffy supergiants might be a warning sign that a star is about to vanish in an instant, leaving behind only a black hole or a neutron star with no visible explosion. This would be an astonishing discovery because it would challenge everything we know about how stars end their lives. Currently, we believe that most massive stars either explode as supernovae or collapse directly into black holes without much outward spectacle. But if puffy supergiants represent a third pathway, one where stars gradually shed their outer layers before undergoing an invisible collapse, then we might need to rethink how many black holes in the universe actually formed. Another possibility is that puffy supergiants are somehow linked to exotic forms of dark matter or unknown quantum effects. Some speculative theories suggest that in extreme gravitational environments, dark matter interactions could create repulsive forces that counteract the normal pull of gravity. If some puffy supergiants exist in regions of space with unusually high concentrations of dark matter, then their expansion could be driven by forces that we don't yet understand. This would mean that these stars are not just a new class of objects, but a potential clue to one of the biggest unsolved mysteries in physics: the true nature of dark matter and its role in the universe. To solve this puzzle, astronomers will need to study puffy supergiants in unprecedented detail. The best way to do this is through multi-wavelength observations, which allow us to see how these stars behave across the electromagnetic spectrum. Infrared observations can reveal the structure of their outer layers, while X-ray and gamma-ray data can tell us whether they are producing high-energy radiation. By combining these observations with precise measurements of their motion and composition, scientists might finally be able to determine what's really going on inside these strange, bloated stars. The search for answers is already underway. Future telescopes like the James Webb Space Telescope and the Extremely Large Telescope will provide new insights into the physics of extreme stars, allowing us to probe their atmospheres and measure their temperatures with incredible precision. But perhaps the most exciting possibility is that we might one day witness a Puffy Supergiant in the final moments before it undergoes a transformation, whether that means collapsing into a black hole, exploding as a hypernova, or fading into the darkness in a way we never expected. No matter what we discover, one thing is clear: Puffy supergiants are one of the strangest, most intriguing mysteries of modern astronomy. They challenge our assumptions about how stars live and die, and they hint at forces in the universe that we have yet to fully comprehend. Whether they are an overlooked phase of stellar evolution, a new class of astrophysical objects, or a sign of unknown physics, they remind us that the cosmos is still full of surprises. And perhaps, as we continue to explore the depths of space, we will find even more celestial oddities waiting to be uncovered, each one offering a new piece of the puzzle that is our ever-expanding universe. The implications of Puffy supergiants stretch far beyond just their own mysterious nature. If they truly represent an overlooked stage in stellar evolution, then they could change how we classify and understand all massive stars. Right now, our models suggest that stars follow a relatively predictable path from formation to death. But if there are hidden phases like this, ones we've barely detected, then our entire framework for stellar lifecycles might be incomplete. The existence of Puffy supergiants suggests that some stars go through radical transformations that we haven't accounted for, meaning we may have to rewrite astrophysics textbooks to accommodate this missing link. One of the biggest challenges in studying these stars is that they exist in a region of parameter space that is poorly understood. They are not quite normal supergiants, not quite hypergiants, and not quite Wolf-Rayet stars. Their extreme size suggests that they should be losing mass at an incredible rate, but many seem to persist for longer than we would expect. If they are shedding layers into space, then where does that material go? Does it form dense nebulae around them, or is it carried away by interstellar winds so efficiently that we never see it? This is another mystery that astronomers are struggling to solve. Adding to the strangeness of these stars is their potential link to massive black holes. If Puffy supergiants are the last phase before a massive star collapses into a black hole, then they could offer a rare glimpse into the final moments of a star's life. Most of the time, when we detect a supernova, we only see the aftermath, the explosion itself and the remnants left behind. But Puffy supergiants could be an early warning sign, a way for us to predict which stars are on the verge of collapsing. If we can find more of them and monitor their changes in real time, we might be able to catch one in the act of transforming into a black hole, something that has never been directly observed. Some theories even suggest that these stars could be responsible for certain types of gamma-ray bursts, the most powerful explosions in the universe. Gamma-ray bursts are thought to occur when a massive star's core collapses in a specific way, directing intense beams of radiation into space. If Puffy supergiants are uniquely unstable, then they might be the perfect candidates for this type of event. Their loose outer layers could allow for a more focused collapse, funneling energy into a concentrated beam rather than a more dispersed explosion. If this turns out to be true, then studying them could help us finally determine the exact conditions that lead to these mysterious cosmic flashes. But what if the instability of these stars has an even more dramatic consequence? Some astronomers have speculated that Puffy supergiants could be prime candidates for what's known as instability supernovae, an incredibly rare and violent explosion that completely obliterates a star, leaving behind no black hole at all. In this scenario, the intense heat in the star's core produces high-energy gamma rays that, instead of escaping, spontaneously convert into matter and antimatter pairs. This process robs the star of its ability to support itself, leading to a runaway collapse and an explosion so powerful that it tears the star apart completely. If these stars do eventually collapse into black holes, There's also the question of what kind of black holes they produce. Most stellar mass black holes form from the remnants of supernovae, but if puffy supergiants have such low densities in their outer layers, then their collapse might behave differently. Instead of a normal core collapse scenario, they might undergo something more exotic, perhaps even forming black holes with properties we haven't encountered before. Some have even speculated that these stars could be linked to primordial black holes, objects that may have formed in the early universe and could be connected to dark matter. If puffy supergiants somehow play a role in their formation, then they could be the missing link between normal stellar evolution and some of the strangest objects in the cosmos. Another major question is whether puffy supergiants are a new phenomenon, or if they have existed throughout cosmic history. If they are rare today, were they more common in the past? Could they have been a dominant feature of early galaxies, when stars were more massive and the conditions were more extreme? If so, then understanding them might help us unlock secrets about the early universe itself. Studying these stars in distant galaxies could reveal whether they played a significant role in the formation of the first black holes and whether they contributed to the reionization of the universe, a key period in cosmic history when the first stars and galaxies transformed the early cosmos. But perhaps the biggest mystery of all is whether puffy supergiants challenge our very understanding of how stars work. Are they truly just a phase in stellar evolution, or are they something fundamentally different? Could they be evidence of an alternative mode of star formation, one that we don't yet understand? If so, then we may need to rethink our entire classification system for stars. Right now, we group stars into categories based on mass, temperature, and composition, but if puffy supergiants operate under different rules, then our current methods of classification might be too simplistic. There's also the possibility that these stars could be interacting with dark matter in ways we haven't yet considered. Dark matter is one of the biggest unsolved mysteries in physics, making up most of the mass in the universe but remaining completely invisible to our instruments. Some theories suggest that certain types of stars could accumulate dark matter in their cores, leading to unexpected behaviors. If puffy supergiants are somehow influenced by hidden dark matter interactions, then they could be the first observable clue to an entirely new branch of physics. No matter what the explanation turns out to be, one thing is clear: puffy supergiants are among the most perplexing objects in the known universe. Their very existence raises more questions than answers, and every new discovery about them seems to deepen the mystery. Whether they turn out to be a fleeting phase of stellar evolution, a new type of astrophysical object, or something that challenges the laws of physics as we know them, they are a reminder that the cosmos is still full of surprises. With the next generation of telescopes, we might finally get the answers we're looking for. Whether it's through direct imaging, spectral analysis, or catching one in the act of collapse, astronomers are determined to solve the enigma of these strange, bloated stars. And as we peer deeper into space, who knows what other cosmic oddities we might find. Perhaps puffy supergiants are just the beginning, a hint that the universe is far weirder than we ever imagined. The more we study these bizarre stars, the more they seem to challenge everything we thought we understood about how stars live and die. Puffy supergiants might not just be a weird exception in the grand cosmic landscape. They could represent an entirely new category of stellar evolution that has somehow slipped through the cracks of our current models. One of the most pressing questions is how they manage to maintain their incredibly low densities while still holding on to their mass. Stars this large and diffuse should, in theory, be completely unstable, yet they persist long enough for us to observe them. This suggests that something is counteracting the normal forces of gravity and radiation pressure, creating a delicate balance that shouldn't exist. One possible explanation is that puffy supergiants have an unusually strong magnetic field that helps hold them together. Magnetic fields play a huge role in shaping the behavior of stars, from influencing their rotation to regulating their mass loss. If these stars have magnetic fields that are orders of magnitude stronger than expected, they might be able to resist some of the forces that would normally cause them to break apart. This could explain why they don't collapse into normal hypergiants, or rapidly explode as supernovae. However, detecting and measuring these magnetic fields from such distant objects is incredibly difficult, so this remains purely speculative for now. Another possibility is that puffy supergiants are surrounded by a thick envelope of material that helps stabilize them. If these stars are constantly shedding layers of gas but also somehow reaccreting some of that material, they might be able to maintain their bloated structure for much longer than expected. This could mean that what we see as a star is actually more of a complex, dynamic system, one where the star itself is constantly interacting with its own expelled material in ways we don't yet understand. If this turns out to be the case, then puffy supergiants might not be a single evolutionary phase but rather a recurring cycle that some massive stars go through multiple times before their final collapse. Adding another layer of mystery is the fact that some of these stars exhibit strange pulsations. Instead of maintaining a steady size and brightness, they appear to expand and contract over time, as if they are breathing. This kind of variability is common in certain types of stars, like Cepheid variables, but the scale of the pulsations in puffy supergiants is far more extreme. Some models suggest that these pulsations could be driven by internal instabilities in the star's core, where the balance between radiation pressure and gravity is constantly shifting. If these pulsations become too extreme, they could even trigger partial eruptions, where large chunks of the star's outer layers are violently expelled into space. These pulsations could also be linked to the way these stars eventually meet their end. If a puffy supergiant becomes too unstable, it might not explode in a traditional supernova but instead undergo a series of violent outbursts, each one stripping away more of its outer layers. This process could continue until the star's core is exposed, at which point it might collapse directly into a black hole without a typical supernova explosion. This would explain why we sometimes see black holes forming without any obvious supernova remnants nearby. Perhaps they were once puffy supergiants that gradually shed their outer layers until nothing was left to explode. If this theory is correct, then puffy supergiants might be responsible for some of the most mysterious black holes in the universe. For example, intermediate mass black holes, those that are larger than normal stellar mass black holes but smaller than the supermassive ones found at the centers of galaxies, are incredibly difficult to explain. They don't seem to form through the usual stellar evolution processes, and yet they clearly exist. If puffy supergiants can collapse into black holes without going through a traditional supernova, they might be the missing link in our understanding of how these intermediate mass black holes form. This also raises the question of whether puffy supergiants could be connected to the formation of binary black hole systems. Many of the black hole mergers detected by gravitational wave observatories involve pairs of black holes orbiting each other, but how these pairs originally formed is still an open question. If puffy supergiants tend to form in binary systems, and if their unusual structure allows them to collapse in a way that produces two black holes instead of one, then they could be the key to understanding the origins of these enigmatic mergers. There's also the possibility that some of these stars never actually collapse into black holes at all. Some astronomers have proposed that puffy supergiants could be linked to a completely different kind of cosmic phenomenon, failed supernovae. In a failed supernova, a massive star reaches the end of its life but, instead of exploding, it simply implodes under its own weight and disappears. If puffy supergiants are particularly prone to this kind of silent collapse, then they could be responsible for a significant number of black holes that form without any visible explosion. But what if some of them avoid collapse entirely? There are theories suggesting that, under the right conditions, a massive star could transition into something even stranger, a Thorn-Zicko object. This hypothetical object is essentially a neutron star that has merged with a supergiant, creating a bizarre hybrid where the dense core of the neutron star sits inside a vast, bloated envelope of gas. If puffy supergiants are somehow related to this process, then they might represent an early stage in the formation of these exotic objects. One of the most exciting aspects of puffy supergiants is that they might not just be confined to our own galaxy. If they are a common, yet overlooked, phase in the lives of massive stars, then they should be visible in distant galaxies as well. With the upcoming generation of telescopes, including the James Webb Space Telescope and the Extremely Large Telescope, we might finally be able to detect more of these objects and study them in detail. If we find that they exist in galaxies billions of light years away, then we could use them as cosmic time machines to study how the earliest massive stars evolved. If these stars turn out to be more common than we think, they could also have implications for our understanding of the cosmic distance ladder, the set of methods astronomers use to measure distances in the universe. Many of our current distance measurements rely on predictable types of stars, like Cepheid variables, but if Puffy supergiants exhibit unusual pulsations or brightness changes, they could introduce new uncertainties into our models. This could mean that some of our measurements of the universe's expansion rate need to be revised, which in turn could affect our understanding of dark energy and the ultimate fate of the cosmos. But perhaps the most mind-bending possibility is that these stars could be linked to exotic physics beyond the standard model. Some physicists have proposed that extreme stellar environments, like those found in Puffy supergiants, could be prime locations for detecting signs of new fundamental particles or interactions. For example, if these stars contain regions of extreme density and temperature, they might produce exotic forms of matter that don't exist anywhere else in the universe. Some have even speculated that Puffy supergiants could be capable of producing micro-black holes, which could give us clues about the nature of higher dimensions and quantum gravity. Puffy supergiants remain one of the most enigmatic and poorly understood types of stars in the universe. Every new observation seems to raise more questions than answers, and their very existence challenges many of our assumptions about how stars behave. Are they a fleeting phase in the lives of massive stars? Or do they represent something entirely new? Are they responsible for some of the most extreme cosmic events, from gamma-ray bursts to black hole mergers? And could they hold the key to solving some of the biggest mysteries in astrophysics, from dark matter to the fate of the universe itself? One thing is certain: the universe is far stranger than we ever imagined, and Puffy supergiants are proof that we are still just scratching the surface of its many mysteries. As our telescopes become more powerful and our theories become more refined, we may finally unravel the secrets of these bizarre cosmic giants. Until then, they remain a tantalizing puzzle, one that continues to defy explanation and remind us just how much we have yet to discover. Puffy supergiants challenge not only our models of stellar evolution, but also our understanding of fundamental physics. Their existence suggests that the boundary between stable stars and chaotic stellar remnants is far more complex than previously thought. If these stars are truly as unstable as they seem, then their ability to persist for extended periods raises profound questions. How do they maintain equilibrium despite their extreme conditions? What mechanisms prevent them from collapsing into more familiar forms of supergiants, or exploding prematurely? These questions hint at underlying processes that we have yet to fully grasp, possibly pointing toward undiscovered aspects of stellar physics. One potential clue lies in their unexpected chemical composition. Spectroscopic studies of some known candidates suggest that they contain an unusual mixture of elements, including higher-than-expected concentrations of carbon, oxygen, and even rare elements associated with the fusion processes deep within a star's core. This suggests that material from their interior is being mixed with their outer layers in ways that defy traditional stellar models. In most massive stars, convection, the process that moves heat and material from a star's core to its surface, follows predictable patterns. However, in Puffy supergiants, this process appears to be far more chaotic, with elements from deep within the star being dredged up to the surface at an accelerated rate. This could explain their low densities and extreme brightness, as their outer layers are constantly being replenished with energy-rich material from below. But what if something even stranger is happening? Some astronomers have proposed that these stars might be powered by exotic nuclear reactions not typically seen in normal stars. For example, in addition to the standard hydrogen-to-helium fusion that powers most stars, some Puffy supergiants might be undergoing alternative fusion processes involving heavier elements, or even strange forms of matter. If true, this could mean that these stars are not just rare anomalies but representatives of an entirely new class of stellar objects. Adding to the mystery is their potential link to long-duration gamma-ray bursts, GRBs. These extremely powerful bursts of energy, which are among the most energetic events in the universe, are thought to occur when massive stars collapse into black holes or neutron stars. However, some GRBs last significantly longer than expected, suggesting a prolonged energy release rather than a single, explosive event. If puffy supergiants are prone to shedding their outer layers gradually rather than in one violent explosion, they might be the missing link that explains these unusually long-lasting gamma-ray bursts. Furthermore, their bizarre structure means that they could play a role in some of the most extreme cosmic phenomena we've observed. For instance, some astronomers have speculated that puffy supergiants might be responsible for certain types of supernova imposters, events that resemble supernovae but do not actually result in the complete destruction of the star. Instead of exploding outright, these stars might experience a series of massive eruptions, each one blasting away a portion of their outer layers but leaving the core intact. This would create the illusion of a star undergoing multiple supernova-like events over time, which is exactly what has been observed in a handful of real-world cases. The idea that a star could fake its own death multiple times before finally collapsing is as fascinating as it is unsettling. It suggests that some of the stars we assume have already died might still be out there, lurking in the darkness, waiting for their final collapse. If puffy supergiants do indeed follow this path, then they might represent a completely new category of stellar death, one where the transition from a massive star to a black hole is not an instantaneous event but a prolonged, drawn-out process spanning thousands or even millions of years. If this theory is correct, it could mean that we've been fundamentally misunderstanding the life cycles of some of the universe's most massive stars. Rather than following a single, predictable sequence of events, these stars might undergo multiple phases of expansion, collapse, and mass ejection before finally reaching their end state. This could also explain why some black holes appear to form in regions where no recent supernovae have been detected, perhaps because the stars that created them did not explode in a traditional way but instead gradually lost mass until only the core remained. There's also a growing suspicion that puffy supergiants could be connected to certain types of fast radio bursts, FRBs, mysterious, ultra-powerful radio signals that appear to originate from deep space. While many FRBs are believed to come from neutron stars or magnetars, some have no clear source. If puffy supergiants are undergoing extreme magnetic activity or periodic outbursts, they could be responsible for at least some of these unexplained signals. In particular, if their outer layers contain tangled magnetic fields, then sudden shifts in those fields could create bursts of energy that manifest as brief but intense radio emissions. These stars might even be key players in the evolution of galaxies themselves. Because of their tendency to shed vast amounts of material, they could be major contributors to the enrichment of interstellar space with heavy elements. Every time a puffy supergiant ejects a layer of its atmosphere, it spreads elements like carbon, oxygen, and nitrogen into the surrounding medium, where they can later be incorporated into new stars and planets. In a way, these stars could be acting as cosmic recycling machines, taking in raw hydrogen and helium and turning them into the building blocks of life before dispersing them back into the universe. This raises the question, could our own solar system have formed from material ejected by ancient puffy supergiants? If these stars were more common in the past, then it's possible that some of the elements that make up Earth, and even our own bodies, originated in one of these strange, unstable giants. This would mean that their influence extends far beyond their immediate surroundings, shaping the very structure of galaxies and seeding the cosmos with the ingredients necessary for planets and life to emerge. One of the most exciting aspects of studying these stars is the potential for future discoveries. With the next generation of telescopes, we might finally be able to observe puffy supergiants in greater detail, allowing us to test some of these wild theories. If we can measure their internal structure, track their changes over time, and detect any unusual emissions, we might be able to determine once and for all what makes them so different from other stars. And if we find that they are linked to exotic physical processes, like alternative fusion reactions or extreme magnetic activity, then they could open entirely new avenues of research in both astrophysics and fundamental physics. As we continue to explore the universe, it's becoming increasingly clear that we've only just begun to scratch the surface of what's out there. Puffy supergiants remind us that even in a field as well studied as stellar evolution, there are still enormous gaps in our understanding. The more we learn about these enigmatic stars, the more we realize just how little we actually know about the cosmos. Are they a fleeting phase in the lives of massive stars? Or are they a fundamental part of the universe's grand design? Do they hold the key to understanding some of the most extreme cosmic events, from gamma ray bursts to black hole formation? Or are they simply an overlooked oddity, a rare quirk of nature that defies easy explanation? Whatever the answer, one thing is certain: Puffy supergiants challenge everything we thought we knew about stars. They blur the line between stability and chaos, between life and death, between the ordinary and the extraordinary. They remind us that the universe is not just a collection of predictable patterns but a vast, dynamic, and often deeply mysterious place. And perhaps most importantly, they serve as a humbling reminder that for all our advances in science and technology, we are still only beginning to understand the true nature of the cosmos. Puffy supergiants push the boundaries of what we thought was possible in stellar physics. These stars, with their immense size yet surprisingly low density, seem to defy conventional logic. They are too large to be stable but too long-lived to be dismissed as fleeting anomalies. If they truly exist in the numbers some astronomers suspect, then they might be one of the most important missing pieces in our understanding of how the most massive stars evolve, interact with their surroundings, and ultimately meet their end. But despite their potential significance, they remain one of the least understood types of stars in the universe. The reason for this is simple: there just aren't many confirmed examples, and their unpredictable nature makes them difficult to study. One of the biggest challenges in identifying puffy supergiants is that they often masquerade as other types of stars. Their extreme brightness and massive size can make them look like hypergiants, luminous blue variables, or even young protostars in distant galaxies. Without detailed spectroscopic analysis, it's hard to tell whether a given super bright star is a true puffy supergiant, or something more conventional. And even when we do find promising candidates, they often change dramatically over time, making them difficult to pin down. This variability might be one of their defining features. Unlike normal stars, which tend to evolve slowly over millions of years, puffy supergiants seem to change on much shorter timescales, sometimes in just decades or even years. This rapid evolution suggests that they are incredibly unstable, existing in a delicate balance between gravitational collapse and explosive expansion. Some theories suggest that they might be in the final stages of their lives, shedding massive amounts of material before collapsing into black holes or neutron stars. If this is true, then studying them could give us unprecedented insight into the final moments of massive stars before they die. But there's another, even stranger possibility. What if puffy supergiants aren't actually dying at all? What if they represent a new type of stellar object, one that can remain in this bloated, unstable state for far longer than expected? Some astrophysicists believe that puffy supergiants might be powered by unusual nuclear processes that allow them to sustain their extreme structure for much longer than traditional models predict. Instead of undergoing the standard hydrogen-helium fusion that powers most stars, they might be generating energy through exotic nuclear reactions, possibly involving elements like carbon, oxygen, or even heavier atoms. This could explain why some of them appear to maintain their size and brightness despite having already burned through most of their hydrogen fuel. If this theory is correct, then puffy supergiants could represent an entirely new phase of stellar evolution, one that hasn't been fully accounted for in our models. But the real mystery is what happens to them in the end. Do they eventually collapse into black holes, or do they explode in spectacular, never-before-seen types of supernovae? Some astronomers have speculated that puffy supergiants could be responsible for a rare and poorly understood type of stellar explosion known as apparent stability supernova. Unlike traditional supernovae, which occur when a star's core collapses, apparent stability supernovae are thought to be triggered by extreme internal conditions that cause the entire star to self-destruct in one massive explosion, leaving behind no remnant. If puffy supergiants are indeed prone to this type of event, then they might be some of the most dramatic and violent objects in the cosmos. Another possibility is that some of them might bypass the traditional supernova stage altogether. In certain conditions, a star's core can collapse directly into a black hole without producing a visible explosion. This could explain why astronomers have observed cases where a massive star appears to simply disappear without any accompanying supernova. Could puffy supergiants be responsible for these mysterious, Vanishing stars? If so, then they might be far more common than we realize, lurking in the shadows of the universe, waiting for their final, silent collapse into darkness. One of the most fascinating aspects of Puffy supergiants is their potential role in shaping the evolution of galaxies. Because they are so unstable and prone to shedding mass, they might be some of the most significant contributors to the enrichment of the interstellar medium, the vast clouds of gas and dust that serve as the raw material for new stars and planets. Every time a Puffy supergiant loses a layer of its atmosphere, it injects fresh elements into space, elements that will eventually be incorporated into the next generation of stars. In this way, these bizarre, unstable giants might be playing a crucial role in the cosmic cycle of creation and destruction, helping to spread the building blocks of life throughout the universe. This raises an intriguing question. Could our own solar system have been influenced by the remnants of ancient Puffy supergiants? If these stars were more common in the early universe, then it's possible that some of the heavy elements that make up our planet, and even our own bodies, were forged in the hearts of these mysterious giants. This would mean that their influence extends far beyond their immediate surroundings, shaping not just galaxies but the fundamental composition of the cosmos itself. But despite their potential importance, Puffy supergiants remain one of the biggest mysteries in modern astrophysics. Their sheer size and instability make them difficult to study, and their unpredictable nature means that they are often overlooked or misclassified. However, with the next generation of telescopes and observational techniques, we may finally be able to unlock their secrets. The James Webb Space Telescope, for example, could provide crucial new insights into their internal structure and composition, helping us determine once and for all whether they represent a unique phase of stellar evolution or something even stranger. And what if Puffy supergiants are just the beginning? If these stars can exist in such an extreme and seemingly impossible state, then what else might be out there? Could there be even more exotic forms of stars waiting to be discovered, objects that challenge our very understanding of physics? The universe has a way of surprising us, and every time we think we've figured it out, something new emerges that forces us to rethink everything. Puffy supergiants are a perfect example of this. They are a reminder that the cosmos is far more complex and mysterious than we ever imagined. Ultimately, the study of these stars isn't just about understanding a rare class of objects. It's about pushing the boundaries of our knowledge, questioning what we think we know, and embracing the unknown. Because if there's one thing Puffy supergiants teach us, it's that the universe is still full of surprises, and the more we look, the more we realize just how little we truly understand. The existence of Puffy supergiants forces us to reconsider fundamental assumptions about how massive stars behave, evolve, and die. Traditional models suggest that the most massive stars follow well-defined paths. Either they burn through their fuel quickly and explode in a supernova, or they collapse directly into black holes. But Puffy supergiants seem to exist in a strange middle ground, neither fully stable nor immediately collapsing. This raises the question, how do they persist in such an extreme state, and how long can they last before their inevitable fate? One possible explanation for their unusual structure is the interplay between radiation pressure and gravity. In most stars, gravity pulls inward while the pressure from nuclear fusion pushes outward, creating a delicate equilibrium. But in Puffy supergiants, this balance appears to be disrupted. Their outer layers are so bloated that the gravitational pull is significantly weaker, making them incredibly fragile. This means that even minor disturbances, such as fluctuations in their internal energy production, could cause dramatic changes in their size and brightness. But what causes this instability in the first place? One theory suggests that these stars are undergoing a late-stage helium-burning process, where heavier elements begin to form in the core while the outer layers expand unpredictably. Normally, this stage leads to a more compact and dense structure, but in the case of Puffy supergiants, something prevents them from collapsing inward. Some researchers speculate that extreme magnetic fields might be involved, creating internal turbulence that keeps the star inflated. Others suggest that these stars could be in binary systems, where the gravitational influence of a companion star constantly disturbs their structure, preventing them from settling into a stable state. Another mystery surrounding Puffy supergiants is their unexpected longevity. If they are truly as unstable as they appear, then they should collapse or explode relatively quickly. But some candidates have been observed for decades without any signs of immediate destruction. This suggests that they might be undergoing long periods of semi-stability, where their bloated outer layers slowly shed mass, gradually transitioning into another phase of their evolution. If this is true, then Puffy supergiants might not be a single class of stars but rather a temporary state that massive stars can pass through under the right conditions. But what happens when they finally reach the end of their lives? Do they explode in violent supernovae, or do they simply fade away? Some evidence suggests that Puffy supergiants might be linked to a rare type of explosion known as a failed supernova. In these events, a massive star reaches the end of its nuclear fuel, but instead of producing a dramatic explosion, it collapses almost silently into a black hole. The only sign of this process might be a brief burst of neutrinos followed by the sudden disappearance of the star from the sky. If Puffy supergiants are prone to this type of collapse, then they could be a missing link in our understanding of how the most massive stars die. Alternatively, some scientists believe that these stars could undergo an entirely new type of supernova, one that has never been directly observed. Because they are so bloated and diffuse, their final collapse might trigger an explosion unlike anything we've seen before. Instead of a traditional core collapse supernova, where a compact core forms before rebounding outward, a Puffy supergiant's explosion might be more gradual, with its outer layers peeling away in massive waves before the core finally collapses. This could produce an unusually long-lasting and luminous event, potentially explaining some of the more mysterious supernovae that have been observed in distant galaxies. The role of Puffy supergiants in galactic evolution is another fascinating aspect of their existence. These stars are constantly losing mass, ejecting vast amounts of material into space. This process enriches their surroundings with heavier elements, providing the raw ingredients for future star formation. If they are more common than we realize, then they could be one of the key drivers of chemical evolution in the universe. Their contribution to the formation of planets, moons, and even life itself might be far greater than previously thought. And then there's the question of whether Puffy supergiants could exist in other galaxies at higher frequencies than we currently detect. Most of the candidates identified so far are relatively close to us, within our own galaxy or in nearby star-forming regions. But if these stars exist in significant numbers elsewhere, then their impact on cosmic history could be profound. Future telescopes, such as the Vera C. Rubin Observatory and the Extremely Large Telescope, may allow us to detect more of these strange objects in distant galaxies, helping us determine whether they are a rare anomaly or a fundamental part of stellar evolution. One of the most intriguing aspects of Puffy supergiants is that they challenge our understanding of what it means to be a stable star. For decades, astronomers have categorized stars into well-defined groups based on their mass, temperature, and brightness. But these objects don't fit neatly into any existing category. They share some similarities with hypergiants and luminous blue variables, but their extreme size and instability set them apart. This raises an important question. Are there other types of stars out there that we haven't yet discovered simply because they don't fit our current models? This wouldn't be the first time that astronomers have had to rethink stellar classification. In the past, we've discovered new types of stars that didn't conform to expectations, such as Wolf-Rayet stars, which burn at incredibly high temperatures and shed their outer layers at an accelerated rate, and magnetars, which have some of the most powerful magnetic fields in the universe. Puffy supergiants might be another example of an undiscovered class of stellar objects, one that requires an entirely new framework to understand. Their existence also raises interesting questions about the fundamental physics of stars. If Puffy supergiants can maintain their bloated state for extended periods, then our models of stellar interiors may be incomplete. There might be unknown processes at play, perhaps exotic nuclear reactions, extreme magnetic effects, or even interactions with dark matter. Some speculative theories suggest that if these stars pass through regions of space with high concentrations of dark matter, they could accumulate enough exotic particles to alter their internal structure, contributing to their strange appearance. While this idea is highly theoretical, it underscores how little we truly understand about the forces shaping these extreme objects. But perhaps the most exciting aspect of Puffy supergiants is what they can teach us about the life cycle of the universe itself. By studying these stars, we gain insight into the conditions that existed in the early universe, when the first generations of massive stars were forming and dying. If we can determine how they evolve and what ultimately happens to them, we might be able to answer some of the biggest questions in cosmology. Questions about how elements are formed, how galaxies grow and change, and how the universe itself has been shaped by the lives and deaths of its most massive stars. The next few decades could be crucial for unraveling the mystery of Puffy supergiants. With more advanced telescopes and observational techniques, we will likely find more of these strange stars, allowing us to study them in greater detail. We may even witness one undergoing its final collapse, providing a direct glimpse into the ultimate fate of these cosmic giants. Until then, they remain one of the most fascinating and enigmatic objects in the universe, a testament to the fact that no matter how much we learn, there will always be more mysteries waiting to be discovered. If Puffy supergiants are as common as some astronomers now suspect, then their existence could redefine our understanding of how the universe has evolved. These stars might be far more than just an oddity. They could represent an overlooked but significant stage in the life cycle of the most massive stars. The sheer amount of mass they shed into space could play a crucial role in the formation of the next generation of stars, influencing the structure of entire galaxies. But for that to be the case, we need to answer a pressing question: are these stars actually stable, or are they just brief, fleeting phases in a much larger cosmic process? To understand that, we need to look at the physics governing their unusual shape. Most stars follow a predictable evolutionary path dictated by the balance of pressure and gravity, but Puffy supergiants seem to defy those expectations. The outer layers of these stars are so expanded and tenuous that even slight disturbances could send them into rapid, chaotic changes. Unlike the compact, tightly bound structures of normal supergiants, these stars appear to be held together by a delicate interplay of forces that we don't fully understand. Could they be in the process of shedding so much mass that they are slowly dissolving into space, or is there an unknown stabilizing factor preventing their immediate collapse? One leading hypothesis involves the role of radiation pressure. Stars this massive produce enormous amounts of energy, and much of that energy is radiated outward in the form of light. If the outward radiation pressure is strong enough, it can counteract the inward pull of gravity, keeping the star in an expanded state. But in the case of Puffy supergiants, this balance appears to be pushed to the extreme. The outer layers are so loosely bound that they may be constantly shedding material, creating vast clouds of expelled gas and dust around them. This could explain why some of these stars appear to have complex, variable brightness. If they are embedded in their own expanding shells of material, then their light might be partially obscured or scattered in unpredictable ways. This leads to another fascinating possibility. Could some of the strangest transient events in the universe be linked to Puffy supergiants? Astronomers have observed unusual, long-lasting supernovae that don't fit traditional models. Some of these explosions last far longer than expected, while others show strange fluctuations in brightness. If these events are tied to Puffy supergiants, then we might be witnessing a new type of stellar death, one that unfolds over much longer timescales than previously thought. Instead of a single, catastrophic explosion, these stars might undergo a drawn-out process of collapse, shedding layer after layer before their final end. If this is true, then some of the most mysterious cosmic events we've detected could be reinterpreted. For example, there are cases where massive stars appear to vanish from view without an obvious explosion. One possible explanation for these missing stars is that they collapse directly into black holes. But what if some of them were actually Puffy supergiants that simply faded away slowly, their outer layers dispersing into space before the core finally gave out? This would mean that we need to rethink how we define a supernova. Perhaps some stars don't explode in the dramatic way we expect, but instead undergo a slow-motion death, one that plays out over years or even centuries. Another strange aspect of Puffy supergiants is their apparent rarity. If they are a natural part of stellar evolution, why don't we see more of them? One possibility is that they are extremely short-lived, appearing only briefly before transitioning into something else. If that's the case, then we may have been lucky to catch the ones we've seen so far. Another possibility is that they are more common than we realize, but they are difficult to detect because their structure makes them look like other types of stars. Some of them might be mistaken for luminous blue variables, while others could be hidden inside thick clouds of expelled material. This raises a tantalizing question: could there be entire populations of puffy supergiants lurking in distant galaxies, waiting to be discovered? With current technology, it's difficult to study individual stars and other galaxies unless they are extremely bright. But future telescopes, like the James Webb Space Telescope and the upcoming Extremely Large Telescope, could provide the resolution needed to identify more of these enigmatic objects. If we find that they exist in large numbers, then they could turn out to be one of the most important contributors to the life cycle of galaxies, shaping the evolution of star-forming regions in ways we've never considered. Another major mystery is what determines whether a massive star becomes a puffy supergiant in the first place. Not all supergiants exhibit this extreme bloating, so there must be specific conditions that lead to their formation. Some researchers believe that these stars might be the result of unusual stellar mergers, cases where two massive stars collide and combine into a single, unstable object. If that's true, then puffy supergiants could represent an intermediate phase between a violent merger and a final collapse. Others suggest that they might be linked to rapid rotation, with their outer layers spinning so fast that they expand outward under centrifugal force. If that's the case, then studying these stars could help us understand the role of rotation in the evolution of the most massive stars. There's also the question of what happens when one of these stars finally collapses. If their cores remain compact while their outer layers are so loosely bound, then their final collapse might be far less violent than a typical supernova. Instead of a sudden explosion, we might see a slow dimming as the star sheds its final layers and its core quietly disappears into a black hole. But if these stars do explode, then the event could be unlike anything we've ever seen. The sheer size of these stars means that their explosions could be drawn out over longer timescales, producing unusual light curves that challenge existing supernova models. One thing is certain: puffy supergiants are rewriting our understanding of how the most massive stars behave. For decades, astronomers believed that massive stars followed predictable paths from formation to destruction, but these bloated giants suggest that reality is far more complex. Their very existence challenges our models, forcing us to consider new possibilities about how stars evolve and die. And as we continue to discover more of them, we may be on the verge of uncovering entirely new aspects of stellar physics, ones that could reshape our understanding of the universe itself. Perhaps the most exciting aspect of studying these stars is that they remind us of how much we still don't know. The universe is filled with mysteries, and every new discovery raises more questions than it answers. Puffy supergiants are a perfect example of this. At first glance, they seem to defy logic, existing in a state that shouldn't be possible. But by studying them, we may unlock new insights into the life and death of the cosmos, revealing the hidden forces that shape the universe in ways we've never imagined. As new telescopes and observational techniques come online, the search for puffy supergiants will only intensify. Astronomers will be looking for more candidates, analyzing their light curves, and trying to piece together the puzzle of how these massive stars evolve. And with each new discovery, we move one step closer to answering some of the biggest questions in astrophysics. What ultimately determines the fate of a massive star? What unseen forces govern their evolution? And could puffy supergiants hold the key to understanding the most extreme stellar events in the universe? These are questions that remain unanswered for now, but one thing is clear: puffy supergiants are far more than just an astronomical curiosity. They are a window into the deepest mysteries of the cosmos, and their secrets may change everything we thought we knew about the stars. Puffy supergiants challenge the very foundation of what we thought we knew about massive stars. For years, astronomers believed that the life cycle of a star followed a relatively straightforward path: formation, main sequence, expansion, and finally, a dramatic end in the form of a supernova, neutron star, or black hole. But these strange, bloated behemoths seem to defy that pattern entirely. Instead of transitioning smoothly from one stage to another, they appear to enter an unpredictable phase where their outer layers become so distended that they almost seem to be floating away. If this phase is more than just a fleeting moment, it could mean that our models of stellar evolution have been missing a critical piece all along. One of the biggest questions surrounding puffy supergiants is just how long they can maintain their expanded state before collapsing or shedding their outer layers completely. If they are relatively stable, then they could persist for hundreds of thousands, or even millions, of years, serving as a crucial but overlooked part of a star's late-stage evolution. But if they are highly unstable, constantly fluctuating in size and brightness, then they might be a sign that the star is in its final death throes. The challenge is that we haven't been observing these objects for long enough to know which is true. Since most known examples were only recently identified, astronomers have no long-term data to track their evolution. This means that, for now, we are left to rely on theoretical models and indirect observations to try and piece together their story. One of the most intriguing possibilities is that puffy supergiants might be responsible for some of the most unusual stellar deaths ever recorded. In the past few decades, astronomers have observed supernovae that refuse to fit any known classification. Some explode with much greater energy than expected, while others dim and re-brighten multiple times before fading out completely. Could these be the deaths of puffy supergiants? If so, it would mean that their final collapse is far more complex than a simple explosion. It might be a drawn-out, multi-phase event where different layers of the star are ejected at different times. This would create a staggered supernova, one that could last for months or even years instead of the usual days or weeks. And if some of these stars don't explode at all? That's an even bigger mystery. There have been cases where massive stars simply vanish from the sky with no detectable explosion. One famous example is the star N6946 BH1, which was expected to go supernova but instead just faded away, as if it had collapsed directly into a black hole. If puffy supergiants are prone to this kind of silent collapse, it would mean that we've been vastly underestimating how many stars end their lives without an explosion. This, in turn, could mean that black hole formation is much more common than we previously thought. Instead of just the most massive stars collapsing into black holes, we might find that a whole range of stars, including those that go through a puffy supergiant phase, can disappear into the darkness without a final, violent burst of energy. Another perplexing aspect of these stars is their internal structure. Unlike typical supergiants, which have well-defined cores and outer layers, puffy supergiants seem to exist in a state of near-fluid instability. Their outer regions are so spread out and diffuse that they might not even behave like a traditional stellar atmosphere. Instead, they could be more like a constantly shifting ocean of plasma, where material is continually moving in and out of the star's gravitational influence. This could explain why they appear to lose mass at such an incredible rate. Rather than a steady stream of stellar winds, their outer layers could be essentially evaporating into space. If true, this could make them one of the primary contributors to the interstellar medium, enriching their surroundings with heavy elements that later become the building blocks of new stars and planets. And this brings us to one of the most exciting implications of puffy supergiants, their potential role in cosmic evolution. If these stars are common, then they might be responsible for some of the heaviest element production in the universe. When they eventually collapse, their cores could create vast amounts of rare elements like gold, platinum, and uranium. These elements don't form easily in normal stellar fusion. They require extreme conditions, such as those found in supernovae or neutron star collisions. If puffy supergiants are prone to undergoing highly energetic collapses, then they might be one of the missing links in the cosmic supply chain of heavy elements. But their influence might extend even further. Because these stars shed so much material, they could be shaping the very structure of the galaxies they inhabit. Supernovae are already known to play a role in regulating star formation, but if puffy supergiants are constantly losing mass even before they explode, then they could be acting as slow-motion triggers for new generations of stars. By injecting gas and dust into their surroundings, they might create the perfect conditions for new stellar nurseries to form. If this is the case, then they aren't just a curiosity, they could be one of the key drivers of galactic evolution. Despite all these tantalizing possibilities, The biggest challenge in studying puffy supergiants remains their elusiveness. Because they are so rare, or at least difficult to identify, it's hard to gather enough data to make firm conclusions. Most of what we know so far comes from only a handful of candidates, which means that our understanding is still in its infancy. Future telescopes, particularly those capable of high-resolution infrared and ultraviolet observations, will be critical in finding more examples. By analyzing their spectral signatures, astronomers hope to determine just how many of these stars exist and whether they follow a consistent evolutionary pattern. And that brings us to the final, most mind-bending question of all: could puffy supergiants be a stepping stone toward an entirely new category of celestial objects? If these stars don't collapse into black holes or explode as supernovae in the usual way, could they be transforming into something we've never seen before? Some researchers have speculated that highly evolved, unstable stars like these could be progenitors of exotic objects, such as magnetars, quark stars, or even entirely new forms of stellar remnants that haven't yet been identified. If true, then studying them isn't just about understanding one odd type of star, it's about uncovering new physics that could redefine our view of the universe itself. For now, we are left with more questions than answers. But that's the beauty of space exploration. Every time we think we have the cosmos figured out, something new comes along that throws everything into question. Puffy supergiants are one of the biggest astrophysical puzzles of our time, and solving their mysteries could unlock some of the most profound secrets of stellar evolution. As we continue to push the boundaries of observation and theory, one thing is certain: these enigmatic giants are far more than just an astronomical curiosity. They are a glimpse into the unknown, a reminder that even in the vast, ancient universe, there are still wonders waiting to be discovered. Puffy supergiants represent a cosmic enigma that forces us to rethink what we thought we knew about massive stars. Unlike traditional red or blue supergiants, these swollen stars exist in a precarious state of balance, constantly teetering between stability and chaos. Their outer layers are stretched to such extremes that they resemble clouds more than solid surfaces, and their internal processes defy conventional models. If these stars are more common than we currently realize, then they could be one of the missing links in our understanding of stellar evolution, an overlooked stage that might be crucial to the fate of many massive stars. One of the biggest challenges in studying puffy supergiants is determining how they form in the first place. Do all massive stars go through this phase at some point, or is it a rare, unstable condition that only affects certain stars under specific conditions? If it's the latter, then what triggers this extreme inflation? One possibility is that a sudden loss of mass, perhaps due to violent stellar winds or interactions with a binary companion, could cause the outer layers of the star to expand uncontrollably. This would explain why some puffy supergiants appear to be shedding mass at an accelerated rate, as they might be in the process of losing enough material to stabilize themselves again. But if this is true, then it raises an even bigger question: what happens next? If these stars eventually shrink back down, then they might not be as mysterious as we think. Instead of being a unique category, they could simply be a temporary phase in the life cycle of some supergiants, similar to how variable stars fluctuate in brightness and size over time. However, if they continue expanding until they reach a critical breaking point, then they could be an entirely different class of celestial objects altogether. Some researchers have speculated that these stars might be precursors to a completely new type of supernova, one that doesn't follow the usual collapse-driven explosion but instead results from a slow, drawn-out disintegration of the outer layers, followed by a catastrophic final detonation. This idea is supported by recent observations of unusual supernovae that don't fit any known categories. Some of these explosions appear to release massive amounts of energy in multiple stages, as if different parts of the star are blowing apart at different times. Others leave behind strange remnants that don't match the typical signatures of neutron stars or black holes. Could these be the deaths of puffy supergiants? If so, then they might be responsible for some of the most dramatic and unexpected cosmic events we've ever witnessed. But even if these stars don't explode, their fate remains uncertain. Some researchers believe that puffy supergiants could be the missing link between certain types of stars and direct collapse black holes. Unlike normal supergiants, which typically go supernova before collapsing, these stars might be shedding just enough mass to weaken their final explosion, causing them to skip the supernova stage entirely. Instead of a violent explosion, they could simply collapse under their own gravity, disappearing from sight in an instant. This would explain why some massive stars seem to vanish without a trace, leaving behind no detectable supernova remnants. Another possibility is that puffy supergiants might be evolving into something even more exotic. Some astronomers have speculated that these stars could be the precursors to magnetars, ultramagnetic neutron stars that emit some of the most powerful energy bursts in the universe. If true, then studying them could provide crucial insights into the formation of these extreme objects, helping us understand why some stars produce normal neutron stars while others become magnetars instead. The problem, of course, is that we have no way of directly observing this transformation in real time. Since stellar evolution happens on timescales far longer than a human lifespan, we can only study snapshots of different stars at different stages and try to piece together their life cycles from there. This makes it incredibly difficult to determine whether puffy supergiants are a common stage in stellar evolution or a rare anomaly. But what if these stars aren't just an intermediate phase? What if they are a completely separate category of stars, distinct from typical supergiants? If so, then their existence could force us to rethink our entire classification system for massive stars. Right now, we divide stars into categories based on their temperature, size, and spectral characteristics. But if puffy supergiants don't fit neatly into these classifications, then we might need a whole new framework to describe them. This could have huge implications for our understanding of the universe. If we've been misclassifying these stars all along, then we might be missing crucial data about how the most massive objects in the cosmos evolve and die. It could mean that our models of galaxy formation, star formation, and even element production are incomplete. And if these stars play a significant role in enriching the universe with heavy elements, then they could be one of the key drivers of cosmic evolution. One of the biggest mysteries surrounding puffy supergiants is their sheer size. Some of them are so enormous that their outer layers extend far beyond what we thought was physically possible. In some cases, their atmospheres are so diffuse that they blend seamlessly into the surrounding interstellar medium, making it difficult to determine where the star actually ends and space begins. This raises an intriguing question. Could these stars be so unstable that they are constantly losing mass at an unprecedented rate? If so, then they might be responsible for some of the largest and most complex nebulae in the universe. And this brings us to another fascinating possibility. What if puffy supergiants are the missing link between massive stars and certain types of planetary nebulae? Right now, we know that planetary nebulae are formed when lower mass stars shed their outer layers, leaving behind a white dwarf at their core. But what if some of the most massive planetary nebulae were actually created by puffy supergiants instead? If these stars are shedding mass at an accelerated rate, then they could be creating enormous shells of gas and dust that persist long after the star itself has disappeared. This could explain why some nebulae appear to be much larger and more diffuse than others. Perhaps they were formed by these enormous, unstable stars instead of the usual low-mass progenitors. But the real mystery is what's happening inside these stars. Unlike typical supergiants, which have well-defined cores surrounded by layers of burning hydrogen, helium, and heavier elements, puffy supergiants seem to be in a state of near-total instability. Their cores might be undergoing rapid fusion, but their outer layers are so stretched out that they barely exert any pressure on the core itself. This could mean that these stars are essentially on the brink of self-destruction at all times, constantly struggling to maintain equilibrium. If true, then they could be some of the most short-lived stars in the universe, existing only for a few 100,000 years before collapsing or disintegrating entirely. And if they are short-lived, then it makes sense that we've only recently started to identify them. Since the universe is billions of years old, most of the stars we see today are either long-lived main sequence stars or the remnants of ancient explosions. Puffy supergiants might be so rare because they only exist for a brief moment in cosmic history, making them incredibly difficult to detect. If that's the case, then every new discovery of one of these stars could provide valuable insights into a process that is happening on a timescale far too fast for us to observe directly. Despite all these unanswered questions, one thing is certain: Puffy supergiants are one of the biggest astrophysical mysteries of our time. They challenge our understanding of stellar evolution, defy conventional classification systems, and might even be responsible for some of the strangest supernovae and black hole formations we've ever seen. As telescopes become more powerful and astronomers gather more data, we might finally start to unravel the true nature of these cosmic giants. But until then, they remain one of the most intriguing and perplexing phenomena in the universe, a reminder that even in the vast expanse of space, there are still secrets waiting to be uncovered. Puffy supergiants raise an even deeper question: are they a natural byproduct of stellar evolution, or do they represent something we don't yet fully understand about the physics of massive stars? If these stars are just a fleeting phase that all supergiants go through, then their existence is expected, even if unusual. But if they are a unique class of stars with distinct properties, then we have to ask, why do they exist? What conditions cause a star to become a puffy supergiant instead of following the more traditional pathways we observe in red and blue supergiants? To answer this, we need to examine the extreme physical processes at play inside these enormous stars. Unlike stable main sequence stars, which maintain equilibrium through the steady fusion of hydrogen into helium, puffy supergiants exist in a state of near-total instability. Their outer layers are so expanded that they barely exert any pressure on the core, creating a strange situation where the core is under immense pressure and heat, while the outer layers are loosely bound, almost detached. This imbalance could mean that these stars are on the verge of total collapse, just waiting for the right trigger to fall in on themselves and form black holes. But if that's the case, then why haven't we seen more of them? One possible explanation is that they exist for an incredibly short period of time. Unlike red supergiants, which can persist for hundreds of thousands to millions of years before exploding in a supernova, puffy supergiants might only last a few thousand years at most. If that's true, then they could be one of the rarest types of stars in the universe, objects that appear briefly before collapsing, leaving almost no trace behind. This might also explain why astronomers have had such a hard time identifying these stars in the first place. If a puffy supergiant only exists for a few thousand years, then the chances of observing one in a galaxy as vast as the Milky Way are incredibly slim. It would be like trying to find a single firework exploding in the middle of an ocean. If you're not looking at the right place at the right time, you'll miss it entirely. This means that even though puffy supergiants could be a common phase in stellar evolution, we simply haven't had enough time to detect them in large numbers. But if these stars are so rare and short-lived, then they must be doing something extraordinary during their brief existence. Some researchers believe that puffy supergiants could be responsible for some of the most powerful supernovae ever observed. Unlike traditional supernovae, which are caused by the core collapse of a star at the end of its life, these explosions might be triggered by the outer layers of the star instead. If a puffy supergiant loses enough mass through extreme stellar winds, it could reach a point where the remaining mass can no longer support itself, causing an explosion unlike anything we've ever seen. This might explain why some supernovae appear to release energy in multiple bursts rather than in a single explosion. Normally, a supernova occurs when a star's core collapses and releases an enormous shockwave that blasts away the outer layers. But with puffy supergiants, the process might be more chaotic. Instead of a single explosion, the star could release several bursts of energy as different layers collapse at different times. This could result in a cascading effect, where the outer layers explode first, followed by the core several months or even years later. If true, then this could be the missing link in our understanding of certain unusual supernovae that don't fit into existing models. Some of the strangest supernovae ever observed have shown multiple energy spikes, as if the explosion happened in stages rather than all at once. Astronomers have struggled to explain these events, but puffy supergiants might be the answer. If their extreme instability causes them to explode in multiple phases, then they could be responsible for some of the most mysterious supernovae we've ever detected. Another possibility is that these stars don't explode at all. Instead, they might simply collapse directly into black holes without ever producing a visible supernova. This idea, known as the failed supernova theory, suggests that some massive stars might skip the explosion stage entirely, disappearing from view in an instant. If Puffy supergiants are among these stars, then they could be responsible for some of the so-called missing supernovae, massive stars that astronomers expected to explode but never did. If this is the case, then studying Puffy supergiants could provide critical insights into how black holes form. Right now, we know that some black holes are created by supernova explosions, while others seem to form without any visible explosion at all. If Puffy supergiants represent a key step in this process, then they could help us understand why some stars produce neutron stars while others become black holes. It might all come down to how much mass the star loses before it collapses. If it sheds too much material, it might explode as a supernova. But if it holds onto enough mass, it could collapse directly into a black hole instead. And this leads to another fascinating question. If Puffy supergiants do collapse into black holes, then what kind of black holes do they produce? Could these stars be the progenitors of the supermassive black holes that sit at the centers of galaxies? Right now, astronomers believe that supermassive black holes form either through the merging of smaller black holes or through the direct collapse of enormous gas clouds. But what if some of these black holes actually started as Puffy supergiants? If these stars are already on the brink of collapse, then they might provide the perfect conditions for the formation of incredibly massive black holes, potentially explaining how some supermassive black holes grew so large so quickly. If that's true, then these stars could be among the most important objects in the universe. Instead of being rare anomalies, they might play a crucial role in the evolution of galaxies, shaping the growth of black holes and influencing the formation of stars around them. If we can learn more about how these stars behave and what happens to them at the end of their lives, then we might be able to unlock some of the biggest mysteries in astrophysics. But despite all of these possibilities, we still have far more questions than answers. How many Puffy supergiants are out there? How long do they last? Do they always end in collapse, or can they evolve into other types of stars? The more we learn about these enigmatic giants, the more we realize just how much we don't know. They challenge our understanding of stellar evolution, forcing us to reconsider what we thought we knew about how the most massive stars live and die. As astronomers continue to search for these elusive stars, we may be on the brink of discovering a whole new class of celestial objects, one that reshapes our understanding of the universe. If Puffy supergiants are as important as they seem, then they could hold the key to some of the biggest questions in astrophysics, from the origins of black holes to the fate of the most massive stars. And with new telescopes and observational techniques, we may finally be able to uncover the true nature of these mysterious giants, solving a puzzle that has baffled scientists for years. If Puffy supergiants are indeed a missing link in our understanding of stellar evolution, then their role in shaping the universe might be far greater than we currently realize. These stars may not just be an anomaly but a fundamental part of how galaxies evolve over time. Their extreme instability, massive energy output, and potential to collapse into black holes make them one of the most fascinating yet elusive objects in space. But to fully grasp their significance, we need to dive deeper into the physics that governs their structure, the forces that shape their lifespans, and the cosmic consequences of their existence. At the heart of every Puffy supergiant lies an engine of unimaginable power, a core so dense and hot that it challenges the very limits of what a star can endure. Unlike stable stars, which maintain a delicate balance between the outward pressure of nuclear fusion and the inward pull of gravity, Puffy supergiants exist in a state of near-total disequilibrium. Their outer layers are so loosely bound that they can be shed into space with ease, while their core remains a hyperdense, unstable mass of fusion reactions teetering on the brink of collapse. This instability means that Puffy supergiants may be among the most active mass-losing stars in the universe. While red supergiants also lose mass through stellar winds, the rate at which a Puffy supergiant sheds its outer layers could be orders of magnitude higher. Some astronomers speculate that these stars may be responsible for some of the densest and most complex nebulae observed in space, massive clouds of expelled material that continue to glow long after the star itself has disappeared. But what drives this extreme mass loss? One leading theory suggests that the radiation pressure inside a puffy supergiant is so high that it overcomes the gravitational pull holding the outer layers together. In simpler terms, the star is literally pushing itself apart, with light itself acting as the force that causes the star to unravel. This could explain why these stars appear so bloated and diffuse. Unlike red giants, which have relatively stable outer layers, the outer regions of a puffy supergiant may be in a constant state of expansion and contraction, almost like a pulsating balloon. If this theory is correct, then puffy supergiants could be one of the primary sources of certain types of cosmic dust, enriching their surrounding environments with heavy elements. This is important because many of the elements necessary for planets, and even life itself, come from the explosive deaths of massive stars. If puffy supergiants contribute significantly to this process, then they might play a more direct role in shaping planetary systems than we previously thought. But this also raises another question: what happens to the remnants of a puffy supergiant after it has shed most of its mass? In many cases, when a massive star loses its outer layers, it evolves into a different type of star, such as a Wolf-Rayet star or a stripped-envelope supernova progenitor. But puffy supergiants may not follow this pattern. Their extreme instability means they might not survive long enough to enter another phase of evolution. Instead, they could collapse directly into black holes, bypassing the traditional supernova stage altogether. This idea is supported by certain astronomical observations. Some black holes appear to form without any visible supernova explosion, leading scientists to suspect that they come from a type of silent collapse. If puffy supergiants are among these silent collapsers, then they could be one of the main sources of stellar mass black holes in the universe. This would make them even more significant than previously thought, as their existence would help explain why some black holes seem to appear out of nowhere. And if these stars do collapse into black holes, then they could be among the largest stellar mass black holes ever formed. Most black holes created from supernovae fall within a certain mass range, typically between 5 and 20 times the mass of the Sun. But if puffy supergiants retain enough of their mass before collapsing, they could produce black holes significantly larger than this, possibly bridging the gap between regular stellar mass black holes and the much larger intermediate mass black holes that astronomers have struggled to explain. This could also have implications for the formation of binary black hole systems. Some of the most massive black hole mergers detected through gravitational waves involve black holes that seem too large to have formed from standard supernovae. If puffy supergiants are producing black holes in a different way, then they could be responsible for some of these unexpected mergers. In other words, the gravitational wave signals we detect today might be the final echoes of puffy supergiants that lived and died millions of years ago. But even beyond their connection to black holes, puffy supergiants challenge our understanding of stellar physics itself. The very fact that such stars can exist pushes the boundaries of what we thought was possible for stellar structures. Their size alone is baffling. Some puffy supergiants are believed to be hundreds, or even thousands of times the size of the Sun, with their outer layers extending so far that they would engulf entire planetary systems. Yet despite their massive size, their low density means they are barely held together. If a spacecraft were to fly through the outer regions of a puffy supergiant, it might not even encounter anything resembling a solid surface. The outer atmosphere of these stars is so thin that it's almost indistinguishable from the surrounding space, making them more like cosmic clouds than traditional stars. This raises fascinating possibilities about their composition. Could the outer layers of a puffy supergiant behave more like a nebula than a solid body? And if these stars are so diffuse, then could they be hiding other secrets within their interiors? Some astronomers speculate that the cores of puffy supergiants might contain exotic states of matter, such as quark-gluon plasmas or even strange matter, hypothetical forms of matter that exist under extreme conditions. If so, then puffy supergiants might not just be massive stars but potential laboratories for studying some of the most extreme physics in the universe. But ultimately, the biggest mystery surrounding puffy supergiants is why they are so rare. If they are just a phase in the life cycle of massive stars, then why don't we see more of them? Are they truly a fleeting stage, existing only for a few thousand years before collapsing? Or is there something else preventing us from detecting them? Could it be that many of these stars exist in galaxies too distant for us to observe? Or do they only form under very specific conditions that rarely occur? To answer these questions, astronomers will need more data. Future telescopes, such as the James Webb Space Telescope and upcoming ground-based observatories, may provide new insights into these elusive giants. By studying their spectra, brightness variations, and surrounding environments, we may finally begin to piece together the full story of Puffy supergiants, how they form, how they evolve, and what ultimately becomes of them. One thing is certain, these stars represent a unique and important puzzle in our understanding of the cosmos. They challenge our models of stellar evolution, hint at new pathways for black hole formation, and may even be responsible for some of the most powerful cosmic explosions we've ever observed. If we can unlock their secrets, we may not only learn more about the life and death of massive stars but also gain deeper insights into the fundamental forces that shape the universe itself. As our technology advances and our ability to study distant stars improves, the mystery of Puffy supergiants may soon be solved. But until then, they remain one of the strangest and most intriguing celestial phenomena, a reminder that even in a universe filled with wonders, there are still countless secrets waiting to be uncovered. Puffy supergiants represent one of the most extreme forms of stellar instability known to science, yet their fleeting nature makes them incredibly difficult to study. Unlike other massive stars that evolve in more predictable ways, these swollen giants seem to defy conventional models. Their existence challenges our understanding of how stars maintain equilibrium, how they lose mass, and how they eventually meet their end. Every observation of a Puffy supergiant is a rare opportunity to glimpse a phase of stellar evolution that is both transient and chaotic. But to truly comprehend these bizarre stars, we need to look at them from multiple angles, examining their structure, their formation, their role in galactic ecosystems, and their ultimate fate. One of the key mysteries of Puffy supergiants is their internal composition. While their outer layers are incredibly diffuse, their cores are thought to be among the most extreme environments in the universe. The extreme temperatures and pressures inside these stars push matter into exotic states that do not exist anywhere else. Some theories suggest that these stars could contain regions of degenerate matter, where electrons are crushed so tightly together that quantum mechanics dictates their behavior rather than conventional physics. In the most extreme cases, the core might even be composed of strange matter, a hypothetical form of matter made up of strange quarks instead of the usual up and down quarks found in normal atoms. If strange matter does exist inside Puffy supergiants, it could provide clues about the nature of neutron stars and even black holes. Some models suggest that if a star's core becomes dense enough, it could undergo a phase transition, turning into a strange star, a type of ultra-dense remnant that behaves differently from both neutron stars and black holes. This raises the fascinating possibility that Puffy supergiants are not just precursors to black holes, but could also be linked to the formation of these exotic stellar remnants. Another major question surrounding Puffy supergiants is how they interact with their surroundings. Because they are so large and unstable, they likely have a significant impact on their local galactic environment. As they shed mass at an incredible rate, they release vast amounts of material into space, forming enormous nebulae that could serve as the birthplaces for new generations of stars and planets. Some of the most spectacular nebulae ever observed might have originated from the remnants of these unstable giants. Additionally, the ultraviolet radiation emitted by these stars could play a crucial role in shaping nearby star-forming regions. Puffy supergiants produce immense amounts of radiation, which can ionize surrounding gas clouds, triggering new waves of star formation. This means that, despite their short lifespans, they may have a lasting influence on the structure of their host galaxies. Some of the brightest and most energetic star-forming regions in the universe could be indirectly shaped by these rare, bloated giants. But the most puzzling aspect of Puffy supergiants remains their end stage. Do they all collapse into black holes? Do some explode in supernovae? Or do they simply dissolve, leaving behind nothing but a faint, cooling remnant? Current models suggest that their fate depends largely on how much mass they lose before reaching the critical point of collapse. If a Puffy supergiant retains enough of its core, it could collapse directly into a black hole without producing a visible supernova, a process known as failed supernovae. In this scenario, the star's outer layers would be briefly illuminated before disappearing, leaving behind an empty void where the star once was. If failed supernovae are common among puffy supergiants, it could help explain why certain massive stars seem to vanish without a trace. Astronomers have already observed cases where massive stars disappeared from their host galaxies without any visible explosion, suggesting that they may have collapsed directly into black holes. If puffy supergiants are among the stars that undergo this process, they could be responsible for the formation of some of the most massive stellar mass black holes in existence. But what about the possibility of an explosive end? Some puffy supergiants might still go supernova, but in a way that differs from traditional supernovae. Because these stars are so bloated and diffuse, their explosions might be weaker and more drawn out than those of compact massive stars. Instead of a single, powerful detonation, they might experience a series of smaller eruptions, gradually peeling away their outer layers until only the core remains. This could create what's known as a pulsational instability supernova, a type of explosion in which a star undergoes multiple stages of collapse and expansion before finally being destroyed. Pulsational instability supernovae are among the most unusual stellar explosions, as they can occur over timescales of decades or even centuries. Some of the largest and brightest supernova remnants observed in space could be the final remains of a puffy supergiant that underwent this process. If these stars do explode in this way, they could be responsible for some of the rarest and most energetic supernovae in the universe, enriching their galaxies with heavy elements and possibly even leaving behind exotic remnants such as magnetars or quark stars. Even more intriguing is the possibility that puffy supergiants could be linked to long-duration gamma-ray bursts, the most powerful explosions in the cosmos. Gamma-ray bursts occur when a massive star collapses in such a way that it channels its energy into narrow, high-energy jets that shoot out into space at nearly the speed of light. If puffy supergiants can produce these events, it would mean that they'd play a role in some of the most extreme astrophysical phenomena ever observed. The connection between these bloated giants and high-energy cosmic events is still being explored, but it's an exciting avenue of research that could reshape our understanding of stellar deaths. Another avenue of study is whether puffy supergiants exist in binary systems. Many massive stars are found in pairs, orbiting each other in complex gravitational dances that can dramatically alter their evolution. If puffy supergiants have companions, their interactions could produce some of the most violent stellar events in the universe. A close binary companion could strip away the outer layers of a puffy supergiant, exposing its core and triggering unusual types of supernovae. In some cases, the companion might even merge with the puffy supergiant, leading to the formation of a new type of hybrid star. If these interactions are common, then puffy supergiants might not just be isolated oddities but part of a broader, dynamic process of stellar evolution. They could represent a key stage in the formation of some of the universe's most exotic objects, including blue supergiants, Wolf-Rayet stars, and even binary black holes. Understanding how these stars interact with their surroundings is crucial for piecing together the full story of their existence. As technology improves and our ability to study distant stars increases, we may soon learn more about these enigmatic giants. Future space telescopes, such as the James Webb Space Telescope and the next generation of radio observatories, could provide new insights into their structure, temperature, and chemical composition. By observing them across multiple wavelengths, from infrared to X-ray, we may finally be able to unlock the secrets of their instability, their explosive potential, and their ultimate fate. But until we gather more data, puffy supergiants remain one of the most intriguing and mysterious stellar phenomena in the universe. They challenge our understanding of how stars live and die, hint at new pathways for black hole formation, and could even be connected to some of the most energetic events in the cosmos. Whether they are rare, fleeting anomalies or an overlooked but crucial part of stellar evolution, one thing is clear: these swollen, unstable behemoths are unlike anything else in the night sky. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.